What is up? Daniel here with the Virtual Robotics Studio, and it is finally time to wire up our robot. A couple notes before we get started. You will need the red bag, the blue bag that were both in the black Kitaparts Kitbot crate. There's also a Anderson connector. This is going to be our main power in. There were 2 SparkMaxes in there, and we may or may not use some of the extra wires in these Molex boxes. But in order to wire the robot, you're also going to need a bunch of parts that you got either in your gray Kitaparts, I think that's the rookie kit, or that you got in a previous year. So you'll definitely need your RoboRio, whether that's a 1.0 or 2.0 from a previous year, or if you buy a new one this year. You'll need 4 more SparkMaxes and the power distribution hub, which again would have been in the rookie kit, or you might have on last year's robot that you have to take off. Of course, you can buy a new version of all of this stuff from Rev Robotics. And the other thing that's not in there, there's maybe a couple wires that we might need when we get to that. We'll mention it. But also, we need some of these terminal lugs. So these are ring terminals for 6-gauge wire. And that will fit on, for example, this cable. We're going to need to put at least one of these on one of those ends, and you'll need these for your batteries. So these came, I believe, in the rookie Kitaparts. If you have any leftover from last year, that's great. If not, go ahead and find any ring terminal that you can. We just want one that has a relatively small hole. So a lot of the 6-gauge ring terminals will have a giant hole in the middle, and that won't work for our batteries. All right, that is all of the major pieces we're going to need. So let's get started assembling this together. But before we do, we're going to give a special thanks to Argosy, first, Aramco, and Team 302, Lake Orion High School, for hosting our studio. All right, so the first thing is we may want to take this board out of our robot, but let's lay out all the components on it, where kind of they're going to go, and make sure that everything fits and we're happy with the layout. And then probably we'll take the board out and actually do all of the attaching outside where it's easier to get to. So first thing is our RoboRio is going to go in this pocket next to the battery, so somewhere around here for that one. And we are going to have the Ethernet cable and a lot of the wiring connection stuff facing in towards the inside of the robot for a few reasons, but like the power, the CAN and the power input here are going to have to go to the power distribution hub, which is the next thing we're going to place. So the power distribution hub, and save all of the things inside there. We're going to need those fuses and probably that USB cable, or one of these USB cables. This is then going to go on top of our RoboRio here, somewhere along this back wall. So we're going to kind of have them next to each other. We kind of want a little bit of room here. We might have to have it hanging off the end a little bit in order for that to work out. Kind of tough here because we are also running into the plastic. So I want to push this kind of deeper in to get more space, but I can't do that. So we'll see if we can get, we might end up moving these bolts so we can move this out a little bit farther, all the way to the edge, because we do need to be able to access these ports to plug in some of our things. So it's possible that we'll have to transfer those bolts out to farther out holes so we can get this just like even maybe with the edge of the wood here. And that seems like that might work. It's kind of like when I'm all the way into the plastic, that's where we're at. I don't want to, if we shove it in too far, we're lifting the plastic up, and that's going to be bad. So this is almost as far as we can go with that one. But we're going to be in somewhere around this neighborhood. That seems good. All right. And then we've got in the red bag, there is a power switch. This is the main power switch. So the battery is going to plug into this, and then this is going to go and feed off to our main power here on the Rev panel. I think there is a world where maybe we go the other direction with this and we move the thing around, but I think we'll start going this way. So that's kind of in the corner there. This kind of wherever we can fit it here. Power switch maybe over here. Not sure. We do want kind of the power switch to not be super accessible. So if we put this way outside here, if a ball comes down and lands on this, that will turn the robot off. So we might try to sneak that in a little bit, or we might mount it out here, but then with the expectation that we're going to mount another piece next to it to kind of be a protection so it can't get hit easily unless we intend to reach in and hit it. So somewhere around here, I think this is going to go. And then what else have we got? We've got our 6 total SparkMaxes. And these are in need of some cutting to be able to open them. Or maybe I could peel the sticker off. All right, there is a sticker on the bottom here. Let's see if we can get that cut so we can open them. All right. So inside this box, you will find a SparkMax. This is the motor controller that is going to control all of our motors. And there are some little pieces that we need to keep track of as well as we go through here. So there is this little plastic clip, a second little plastic clip. We're going to be using both of those. And then we've got a couple different wires that we can plug in to use stuff. So don't lose any of that stuff. But we're going to do a SparkMax. We need, let's see, we need like at least one SparkMax on this side if we can. What we're going to try to do is make it so that on the SparkMax, one side is labeled V plus and V minus, and the other side is ABC, and that has 3 wires, including a white wire. We want to make it so that the red and black wires can plug into our PDH without needing to add extra wires onto them. So we might be able to get this into these 2 here. Yeah, I think we're definitely going to have to move at least one of these bolts so we can get our RoboRio a little bit more out of the way. And that's fine. Maybe we'll pick either I think maybe we'll remove the inside bolt. And I did say we only really need 1 bolt, so when we put this back in, maybe we'll just put that 1 bolt in. Okay. So this would just barely fit. So we're going to have 1 SparkMax over here somewhere. Let's keep opening SparkMaxes. Oh, that one doesn't have a, okay, all right. Some of mine might be a little older because they did not have a sticker. Or maybe the stickers are the old ones, I don't know. All right. Don't lose all of my extra pieces. Again, don't lose all of the extra pieces. All right, so there's going to be at least 4, probably on the other side here. Walk around. And again, I'm going to face the red and black wires in. So if we go in this way, with 4 of them going across, I think we can just get 4 of them on this wood piece. Looks like one might be sticking off the edge a little bit. That's okay. But that will reach. And I think we can use this side. We just won't be able to adjust that while it's in the robot. We'll have to do that when it's outside the robot. But this would be the farthest one. And that will not reach over to this side. So we're going to definitely have to use both sides. If that's the case, we might be able to do like a row of 3. Actually, maybe we can just turn them when we put them in. Does that reach? That does not reach. Okay, so we're not going to be able to turn them. We're going to have to keep our 4 going this way. All right, that seems pretty good. And then we're going to have to sneak a 5th one in. We may either have to extend the wire on the 5th one on this side, or maybe we can sneak 1 more. I think we can sneak 1 more on our original side over here next to our RoboRio. All right, yeah, I think that works. Maybe we can even go 2 next to each other here. And the power switch, they do all fit. Not sure, maybe we'll do it like this. Okay, that looks good. Everything fits. We've got a lot of space over here still that I don't know if we're going to use on the far side, just because we want to be able to get our wires in and touching. OK, I think our next step then, we kind of have an idea for the layout. It feels like everything fits and reaches. We know, for example, these wires from the top, from our launcher and our intake, these, we're probably going to run them out to the side here and then maybe down the outside. They're not going to be long enough to reach no matter what, so we're going to have to extend these wires out. That's fine. That's expected. And then from the drive, these wires, I think, are long enough, right, that if I can reach underneath the robot and pass some out, you can see there they are. Well, they are very long, so this will reach anywhere we want to put it without having to extend those wires. So that makes sense. And then the only other wires we have coming out will be for our robot signal light and our radio when the time comes. All right. So I think what I'm going to do now is I'm going to pull all these things off. And I'm going to go ahead and unscrew the whole board and remove that from the robot. And then we will rejoin you when we have that board out so we can start attaching our components to it with lots of space when it's free from the robot. All right, back with a little more space because the robot's gone and we've got our electrical panel outside of the robot. So the last time it was in the robot, it was in this orientation. So I'm going to keep it in this orientation. So we had the battery here. The RoboRio was going to go maybe even hanging off the edge a little bit towards the inside here. So I have room to use this bolt hole. Our power distribution panel, or power distribution hub, sorry, is going to be somewhere on this edge. And again, we might hang that off the end. We'll see how easy it is to use these. Like I kind of want to be able to get to these even when it's in the robot, just in an emergency. So I don't want it so close that you can only do it if you take the RoboRio out. So we'll see. We can maybe cheat a little bit too and just hang out off the edge of the board a tiny bit. Oh, we can't actually hang off the edge of the board, right? Because the plastic ramp was going to hit. So we are pretty much set on the back of the board with this. And then it looks like we can cheat the RoboRio forward for extra space. All right, our fuse was somewhere over here. We had our SparkMaxes with the red and black wires going towards everything that we want over here. And we were going to try to just fit 4 across if we can. And then we've got the 2 on this side that we're going to either do in this orientation or this orientation with our power switch. I think probably I'll leave a little bit of extra room for the power switch here. OK, and the power switch, there is one more thing that we do have to be a little careful of, and we'll kind of hope it doesn't happen, but there is the inside frame rail that if we try to drill holes and mount this, we might end up hitting. So if that happens when we put it back in, we'll just, when we line the board up to check, we'll just take it out and drill some new holes. All right, but that is our basic setup. I think the first thing is our hub is pretty much set here, because this is as far as we can move it back before the ramp starts hitting. And I guess we can shift over left or right a little bit, and that's really our only options. So I am going to, do we want to cheat over a little bit at all? That just dictates where this guy can be. So if it's right next to it, that's still fine. And this one that's going to go here, totally fine. All right. If we cheat over, does that help us at all on the other side? Not really. Not really. So I'm going to leave just a tiny gap in this corner before trying to attach it down. And you have some leeway here. You don't have to be exactly where I am, but if you care, I'm going to be about 6.5 inches in from this edge is where I'm going to mount this. Okay, and I'm going to just kind of make a couple of marks just so if I move things around, I'll know how to line it back up. And for most of the things, I'm going to mount it with this, the rest of the hook and loop that we have, or what is dual lock? I don't know what this stuff is actually called, but this Velcro or Velcro equivalent. But the power distribution panel is kind of heavy, so that we might do some bolts, or we might add some zip ties. So I'm going to, it doesn't reach. So, all right, well, you can maybe mark the holes. We might come back and drill those holes later. All right, so that's where that's going to go. And I think let's actually just get it attached. So I'm going to take the panel out. I'm going to do, let's see, we have lots of this stuff, I think. So I'm going to do kind of 2 long strips, 2 short strips with one in the middle. That seems good. Let's do that. All right, so we'll just kind of measure about how long this is across, and we'll go 1, 2, and 3. Okay, and I'll peel one end off and stick it down. I'm not going to cover the holes, because we might still want to use the holes. So one of the things is, if we put the Velcro on, or the dual lock on, and then it feels like it's not sturdy enough, it's not going to hurt anything to have that in between, right? So then, a zip tie going around it or a bolt holding it down will just, make it more secure. But this is going to help us get it laid out and sort of mounted quickly. Okay, and then the last one, just make sure you don't cover the holes. Oop, that slid. Stay lined up. Okay. So then what we're going to do next is peel. And we'll give it a quick wipe to make sure there's no sawdust. Honestly, the cleaner you make this, probably the better it is. But it usually works out for me. All right, and double check that your big power inputs and the yellow and green ports are going to be facing towards the shorter side. And then, and the Rio. Just basically make sure your orientation is still good here. And then I'm just going to line it back up with my holes as good as I can. And push down on that. Okay, and the good news is we're mounted here, but so far we haven't done anything else to it. So if we have to peel this off, we could still shift it this way very easily. And even we can go left and right a tiny bit. So that seems good for that. Next up is our Rio. And what we want to do is we want to be able to put wires in here. We're actually going to power the RoboRio from these ports. And we want to put wires in here. So actually, maybe we'll save this for later. Let's move on to, let's try to do our SparkMaxes on this side and see what we can get going there. Okay, so the 2 in the middle are going to be easy. The ones on the end are going to overhang a tiny bit for me. But I want to mount these when they are plugged in, so I know that the wires are going to reach. So next thing we need is a wire stripper. So if you have the kind that you got to that look like pliers, and you squeeze down and twist it and pull the end off, that works. The kind I have are automatic, so I just kind of line it up and pull the thing and it'll pop the insulation off for me. When we are stripping these wires, you have a pretty big amount of leeway for how much you strip. I'm going to be looking to do about that much on these, and I would say that's probably around 1/2 inch, just under 1/2 inch. So that looks, yeah, I'm just under 1/2 inch on that one. So somewhere around there is going to be good. And we're stripping the wires that are V plus and V minus right now. So one side is labeled V plus and V minus, the other side's ABC. V plus and V minus is for the source voltage, which our power distribution hub is going to deliver. So I'm going to strip 2 of the wires here. And then what we can do is, I kind of grabbed a brand new one. We are going to try to line this up, right, so we can plug in. I guess we can get as close as we want here too. It's nice to have just enough room to be able to have the wires fit. Like if I jam it in so they're touching, that's just a little bit less pleasant to work with. So, and we're gonna have 1, 2, 3, 4. Anything farther back is not gonna reach anyway, so we're gonna have to extend the wires. So this one I think is gonna go into the second port here. So in my case, that's gonna be 8, the second one from the end. So to use this, you lift up the levers and they'll lock open. And then we're gonna push in one of the wires, so the red wire goes into the red spot. And then just push it down. And then once it's pushed in like that, I'm gonna do the black wire next. Same thing, put it in all the way, push it down. Then the next thing you wanna do is you wanna give this like a legit tug. So I'm gonna grab this and I'm gonna pull. And if it comes out, it wasn't in all the way, all right? It should not come out. Once that's set, now we know this is gonna be right around here. Okay, cool. Let's actually go ahead and strip 3 more of these wires off. So we'll bring the other 3 that we're gonna go on that side. And we're gonna work on that V plus and V minus side. So same rough amount of stripping. We want about that, you know, whatever, 1/2 inch, give or take a little. And we'll keep going. You'll know if you stripped too much of the wire insulation off if, when you go to put it into the housing, oh, that one. Didn't quite work. All right. There we go. Okay, and the last one. What was I saying? Yes, when you go to put this into the housing, so if you have this open and you put the wire in, if you see exposed wire sticking out, then you strip too much. All right, let's go through now. And so the first one's here. Let's take a second one. Lift up the 2 ends on that side. And this one probably could go the other way if we wanted to, but we might as well put 2 and 2. So I'm gonna go into 9 with this one. Red wire in, close it down, give it a tug. Black wire. And you don't really need to twist the wires. Like they go in flat, that works fine. But if you do have some of the wires that are sort of like spreading out on you, then yeah, you can give it a little bit of a twist just to keep them together. And we'll go in with that one. Give it a tug. That looks good. All right, so we've got kind of 2 that are gonna live something like that. And we don't hate that. Okay, and then the next one in the middle here is probably going to go on the end. So I'm going to go in, this is 10. Stay open. All right. Black wire goes in, and we close, and tug on it. Red wire goes in, and tug on that one. All right, looks good. So that's going to be in the middle here, and then we've got the last one to the outside. So we'll open up on 11. And once again, we'll slide the wire in. Close, tug, looks good. Red wire, and tug. All right, so those tug tests are really important. One of the biggest problems that you could face with your robot is just having a loose wire. If there's a loose connection somewhere, things sort of work, but not really work. And that's like almost the hardest thing to deal with. Huh, all right, so we have like kind of a lot of space here. Do we want to try to fit one more? Like chilling like this? You know what, I think I do. I think I'm convinced. All right, so let's take a 5th one now, and we're gonna strip those wires down. Also, if you really want to embrace the electrical life, make sure you don't clean up the insulation. Leave that for somebody else to clean up. All right, we're going to go to 12 with this one. And slide the black wire in, Tug, looks good. Red wire goes in. And tug, that looks good. All right, so I think actually this is going to be the one we set first. This one we want to live more or less right next to the hub because there's still room for the other ones to go in and fit. So we're going to do this one here. I don't think I need to mark this one. We're just going to open it up. And let's see, how do we want to do this one? We could do 2 long strips and just be way covered. We could do 2 shorter strips as well. These ones are going to be a little different because they are going to hang off the edge. So those ones are going to need long strips for sure. So all right, let's just do long strips. That seems good. All right, so I'll get a strip. Basically, I want to cut it so it sits inside the screws just in case we got to, I guess there's almost no situation in which you're going to undo those screws. So you don't probably need to worry about that. But we're going to do 2 of these little Velcro strips here. Okay. All right, a little wipe, peel the ends off. And then I'm going to leave just a small gap in between the 2. So, it's not going to rub when I try to take them apart. Might be a little easier if we have to disassemble to work on stuff. Just push that down a lot. And I don't think that's moving anywhere. Again, if we had to, we could. The way these work, they have the same grooves for a zip tie. So if we took this out, we could drill a hole underneath it, pass a zip tie through here, drill another hole on the other side, zip tie up, and lock it down on the top. But right now, this feels pretty secure. So we'll start here, but if you have trouble where they keep popping off and running free, then you want to look to add a zip tie. Another easy way to do this zip tie, since this sort of flies through space, we could probably just zip tie like all the way around in between the wires, the whole board like this as well. And that would work, but again, we'll get to that later. All right, next up, let's get our other ones mounted. So let me see here. I guess these 2 coming in, it's about like that. I want to try my best to make sure I have the same amount on both sides because each of these then will have, to hang off the edge just a little bit. So that's going to be the goal. All right, so we're going to flip these 2 over and get some Velcro going on the bottom of them. Might as well keep doing it the same way. 2. And in fact, I'm going to cut 3, 4. So this is enough for the middle 2. We could do the next step, but I'm just going to keep cutting. We need 5 and 6. Potentially for our next SparkMax, and 7 and 8 for the one that's going to sit on the other side. And then actually we have one more SparkMax, right, that we're going to put on the other side. So we need 9 and 10. And we still have plenty left for our RoboRio. All right. Let's get these out of the way. I'm going to stick 2 on. Each of the 2 that we're going to go in the middle here. And then let's stick 2 on the other middle one. Okay. And I'm going to peel all 4 of these. I kind of want to put these 2 down together because it makes it easier for me to guess where the center is. Okay, so this is going to go this way. This one is going to go this way, untwisting the wires. Go right next to each other. And I'm going to leave just a little bit of room, kind of like when those wires start pushing back, I'm going to kind of stop forcing it forward. And that looks pretty even on both sides. So let's go ahead and squeeze those down. Okay, then we got our next two that are going to jump in right next to it. And for these two, because the Velcro is not going to have something to stick to if we put it on the edge of the SparkMax, of our speed controller, I'm going to go ahead and put the Velcro like really close to the other one we have here. And I think I should have done it on the edge of the wood first. That would have been the first choice. But I think we should have just enough room to put this second one right on the edge of the wood. And let's do that in the opposite order on this one. So I am readjusting these to make sure they're lined up just because there's not a lot of extra space in between it. So I'll peel it apart and square them up if necessary. Now on this side, we're going to go start it right on the edge of the wood. And then I will recenter this one as well. And then this one is going to go, yeah, I think we have room to sneak that in next to it. Perfect. Okay, and then we can peel the two off of that side. And bring our other speed controller back. And I'm going to keep it nicely in line, but you know, if it's a little bit one way or the other, doesn't really matter. And push that down. And then same thing as we spin this back to the original orientation here. Okay, and then we've got the same thing on this side. All right, and then with this, like again, if we had to, if it feels like these ones are getting loose, it's going to be very easy for us to take this zip tie, and we can go all the way around everything. And of course, if your zip tie is not long enough when you try to do something like this, you can always chain zip ties together. So if you take another zip tie and put it in, that works. And I'm pretty sure if we go, you know, like all the way till that one's flat and then bring this one down, I guess I'm adding the zip tie right now, just to give you that example. So we've come this far, all right? So that's pulled on and tight. The middle ones are getting a little bit less support, but the middle ones also can't really fall out as easily because they're blocked by the other ones, but also because there's the dual lock on the bottom, the hook and loop, the only way for these to fall out is if they lift up first, because they can't slide because they're locked into the Velcro. And now they can't lift up because the zip tie's there. And again, you could do 2 zip ties if you wanted to. I'm just going to stick with the 1 for now. And remember, you can always go back and add these zip ties if you run into trouble later as well. All right. So now we've got all of our other wire ends. These ends are going to go out to the motors. We'll come back and deal with those in a second. Let's now look at the other side here of our board. Again, we're saving the RoboRio for last-ish. So we've got this other SparkMax that we have to fit here. We could go right here next to the RoboRio. The only reason why I don't love this is because the wires on the other side need to go this way, right? Because our motors were back in the frame of things. So if we go here, at least it's sort of like, you know, bridging around the gap. So I think I'm going to go in sideways like this in that spot. So let's strip the wire ends here. Huh. Didn't like that red one again. All right, there we go. Okay, and we'll just go right into the first port. That's going to give us the most freedom to move around. So red into the red one. Lock it in, tug on it. Black into the black one, lock it in, tug on it. That seems good. All right. And we know this is going to be somewhere around here. So I think I want to have a little bit of a loop on these. Just helps to not have anything pulled too tight. And let's flip our SparkMax over and get our Velcro, our hook-in loop, installed on the bottom. All right, we'll peel them. Like I said, get just a little bit of a thing. And I'm going to be close to the edge of the wood. I remember this wood was close to the wheel, so I will leave a small edge there just in case. All right. Next up is our fuse. We got to figure out how to do this. And remember, I wanted it pretty far in if possible, just to kind of protect that button. But we may, again, have to look to adding some extra stuff there later to help out with accidental button presses. But we want to be pretty far in here. But one of the issues of being too far in is we need, let's see, from the red bag, we've got some of that heavy-duty 6-gauge wire. And there are, you should read the rules, there are electrical rules saying what gauge wire can feed what. Now, of course, you're always allowed to use whatever's on the board. So like this SparkMax wires have to be legal. But if we need to extend the wires, which we're going to have to do on our other SparkMaxes on the other side, when these get extended, we're going to have to make sure we use the right gauge wire for that. Turns out main power in from the battery has to be 6-gauge wire or bigger. So that's why I got to use this big stuff. Now, this plug is going to attach to our battery. And actually, our battery is over here. So that's pretty far away. I think there might be a world where we have to put this. Well, I guess it doesn't. We're kind of stuck either way. So in one case, in one end of this, the black wire is going to go into the black main power battery input here. Then the red wire actually has to go to the switch. So this is kind of the farthest over we can go. And I don't know. Let's see. I think I want to bring the robot back. Let's throw this back in the robot and do a couple checks and see how we're going to deal with that. We might end up just not mounting the connector to the battery, the mount that had a spot for it in order to get this to work. But really quickly, the other end of the red wire is going to go to the power switch. And then the other end of the power switch, we're going to need to take a red wire and go into the red port here. Battery port on the PDH. All right, so give me 1 second. We'll be right back with the robot here just so we can take a look inside and make sure things are going the way we want them to go. All right, so I'm going to slide this into the robot just to check that we didn't do anything crazy and that we're still in good shape. We are also a little worried. We're going to check our battery connector, of course. We're a little worried about the SparkMaxes that I let you hang off the edge, or that I chose to hang off the edge. So we'll see how that goes. It's like we got all these wires now that are getting in the way. All right, if we lift those up. Okay, yeah, we're good. Actually, you know what's interesting? The only thing hitting right now and stopping me from putting this exactly where I want it is the head of the one zip tie that I was like, I guess I'm putting this zip tie on. So if I have that zip tie head in a different location, that would work. Because the regular zip tie is there, but it is just hitting this battery bracket and causing some problems. And these bolts that I had us loosely put in here, because we're going to use them later, are also a little bit in the way. Otherwise, everything fits. The floor is just, again, like we knew, is just barely above our power distribution hub in this location. I don't think it's a problem. It's definitely still sloped down, and no balls are going to get stuck. So I think we're happy with that. Oh, one of my battery flaps went flying. All right, we'll find that later. But then this wire, there's sort of no way this is ever going to get over here to mount to the battery mount, to attach to the battery mount. I think probably what we're going to do is just plug it in without using that attachment point. So attaching, what you can do is you can take these connectors and you can attach that onto the little tab that's sticking up from the battery mount here. That's nice because it makes it so it doesn't move around so much. But if we think about it, if the battery comes in here like this, we definitely have room to plug this in, right? And then this wire will kind of be hanging out in the air above, should be high enough above the RoboRio that we're not super worried about it, right? Because our RoboRio is going to be like down there. And then when the floor flap comes down, it's going to sort of be pressing up against that. And that seems pretty reasonable. Like it's going to stay inside the robot. It's not likely to get, caught on anything. And we can always bend these wires as needed to keep it from lifting that floor flap up too much. So I think that is going to be our solution for that. All right, so that means let's get this back outside of the robot. All right, that one doesn't need to be plugged in. We'll get back to that one later. And then these couple tiny bolts that we were saving, I guess we're not going to use those, so I'm going to undo it. I'll probably still try to save them somewhere, but I know by the time I need these next year, I'll have no idea where I put them. All right, I'm going to move the robot away. We're going to finish wiring up the rest of our electrical panel. All right, we're back over at the table. So the first thing was, if you remember, this zip tie was hitting for me. So I'm going to, I guess, just remove it for now. If we were worried, again, this outside rail, there was nothing close here. And also, of course, for the one that we had it on, if you need it again later, as long as you make sure that the edge here is just flat zip tie, it's going to be OK. It's just that the head of mine was right on the corner, and that was banging into our battery mount. All right, our next problem is the power switch. So let's see. We're going to mount this somewhere around here. And we talked about, like, oh, if it's a little bit too far out, this button might get exposed. If it's a little too far in, we might have a problem being able to press the button. And then if we use the bolt holes, like getting it lined up perfectly around the frame rail also seems a little tricky. So I did also look at this. I think if we put it about, let's say 2.5 inches from the end of your plate, if we go 2.5 inches from the end of the box here, or the wood, that is going to make it so that this button is just barely outside of the plastic hopper that's sticking up. And so it's going to be mostly protected, and then maybe we could rivet something onto the hopper if we need more protection. And then I think the inside bolt hole is going to be free. The outside bolt hole, I don't know, that might hit the frame rail. So I think what we can do is we can drill that inside hole and use that to put a bolt down. And then the outside one, I don't know. And we might do is we might combine. I don't know if this is thick enough to get down past the actual mounts here. We could try a couple pieces. One of the problems is because this has these raised feet and it's kind of a hole in the middle, we can try to put this in the middle and hope it's tall enough that it sticks. Sometimes it's not tall enough, so it doesn't actually stick together. I think this might just work. So we can try a couple of those, and if we get some Velcro that's working and that one bolt running through, it's not going anywhere. The only reason why I don't want to just do the Velcro with this is when the power cable is connected, it's this big, heavy cable that you're going to be moving around a lot to plug in your battery and unplug it, and that tends to make these things pop free. So I definitely like getting a bolt or at least a zip tie to help hold this, this piece in. So again, let's just go ahead and make a mark at about 2.5 inches in. And front to back doesn't really matter. So that's about 2.5 inches in. And if we line the edge up, I guess I'll cover the line. It's probably safer to go a little bit too far out than too far in. And I'm just going to center it in this space. I could go right next to the SparkMax. That doesn't seem great. I could go next to this edge, but I know the wheel is really close to that edge, and we got all kinds of other issues. So I'll center it. I'll kind of cover my line. So I won't be more than 2.5 inches in. What might happen is if you mount this too far in, and this button is completely under the hopper, it is possible that an inspector will look at your robot and say that button is not in a safe place. That if there was an emergency and somebody had to turn your robot off very quickly and they have to reach under and just barely have room for their finger to get under the hopper to press the button, they might make you move it. So I think if we're just outside the edge, if we're just at 2.5 inches or so, or less from the edge, then that button is just outside the hopper, so it's going to be easy to press and you shouldn't have that problem. All right, then let's see if we can get a dot here for where to drill that hole. That worked, yep. And I can put a dot for the other one too. We might as well drill the hole. I don't know if we're going to be able to use it when we put it in the robot. That other hole might collide with something. So I've got 2 dots roughly where we want to drill some holes. So let's get ourselves some safety glasses and a drill. And we're going to use for this, just because it's what we have, these inch-long number 10 bolts. It's a little big for it, but it seems like it'll catch. I think these are probably made for 1/4-inch bolts, but we don't have any of those in the kit of parts, so we're just going to use what we got. And that means if we're using a number 10 bolt, we're going to look for that number 7 drill bit, or 0.201 inches. Of course, if you only have a 3/16 drill bit, that will work here, but you might have to drill up and down a couple times to make sure you really knock all of the wood out of the way. All right, so we'll tighten this. Get the RoboRio out of the way. And we're drilling wood, so wood shavings are luckily not conductive. If we were drilling aluminum or metal, I would be much more worried about the electrical components here. But instead, let's just get this off the edge of the table so that we don't drill into the table. And because that hole is really big on the switch, we don't have to probably be perfectly aligned here. All right, so we can line up on the hole and just drill all the way through. And then I'm going to do the other one, even though I'm not sure if we really need it. All right, looks good. Set the drill down over here and get the tools to mount. All right, so we'll flip this back over. And we're going to try to do one right now, and then we'll worry about another one later. If you're worried about how loose this bolt is, you could throw another number 10 washer on your bolt first, and that'll help spread the forces out. But I think it's going to be fine without it, so I'll try just going straight through. Okay. There is a small chance. I don't think so. I think this is far enough away from the motor. I don't think there's anything under this. So there's a small chance that because this bolt is a little bit long, actually it's not that long. Okay, you probably can't use a washer, because when I look at the other side, it is just barely making it through. So unlike before when this bolt was way too long, we have roughly the right size for this one. All right, so we're going to get that started. And then we'll throw the wrench on it and tighten that down. We can tighten that down all the way. Well, that is just exactly the right size, all right? So I can see that we are into the plastic, so the nylock is working, and then we are bolted on. Now, we'll leave that other one. That hole does line up. We can use it later if we need to. I did say we were going to try to add Velcro too, so I guess let me undo this, and let's add the Velcro, because that's going to help. One bolt, obviously it can still spin, so we need something else to help hold it in place. And if we aren't going to have space for that second bolt to go in, then this dual lock it's going to be, or this hook and loop it's going to be. All right. Let's kind of center that up. Okay, and sure, we'll cut it roughly the width of the thing here. Got to go in just a little bit. And let's make 2 of them the same. All right, and now go ahead and put these 2 on. Okay, now the tricky part is we have to peel it off. We have to line it up. Also, I'm making it so that the switch is to the inside. So that'll protect the switch a little bit more. You'll have to reach in and get it to pop on. That'll be a little bit harder for you. But remember, the hopper slopes up. The floor of the hopper slopes up. So having the button on our SparkMax side here is going to give it just a little bit more space for your fingers to fit in. All right, so I'm going to now, with the Velcro, or with the adhesive hook and loop on there, we got to get it into the hole and bring it straight down. I'm going to line up the other hole as well. So I'm just eyeballing this hole to make sure it's lined up. And then I'll push down, and it looks like, yes, we do have some adhesion. So that is good. Then we can go ahead and tighten this back on. And actually, when we tighten this bolt, that should even stick it more because we're going to pull it down into the Velcro. So that's going to help get that Velcro set up even better. All right, so we'll go ahead and screw that in so it's nice and tight. And of course, the bottom is wood, so we could keep crushing into the wood. So I'm going to stop when it's tight. That was actually probably slightly too far. I dug into the wood a little bit. Oh well, it's going to be all right. OK, and that is not rotating. So that means the hook and loop is set and is working. So I think we're probably good. Again, we can add the second bolt if there's space. If not, it seems fine. All right, now we know that we need this. We can either connect to here with a ring terminal and have this going across like this to our battery, or we can connect to this one and have it going across like this to our battery. I think this one's probably slightly better, right? But let's see if we can get this small short cable to work first, because that is actually the harder cable to deal with. So let's get a piece of red 6-gauge wire. And we're going to have to strip one end of this wire. I don't have a wire stripper for 6-gauge. You probably won't either. There are a few different ways you can do it. If you got your, probably these are too small, but if you have a bigger pair of diagonal cutters as well, you might be able to kind of go on there and start cutting and turning. You can probably do that with scissors too, especially if you have a nice sharp pair of scissors. You can probably like cut in a little bit and rotate the thing as you go. And that looks like it's working really well. That's probably going to be my preferred method. You could also, if you're careful, with like a knife or utility knife, you can cut in and rotate in order to cut all the way around. And this is usually the way that I'll do it. So you just go nice and easy all the way around. You don't have to push hard. Remember, there's a sharp blade right next to your fingers, so take it slow. And then you got to kind of like pull and wiggle that. You might even want to grab a pair of pliers to help you out to get that off. So if you wiggle it a little bit, you kind of have a gap going, then you can kind of reach in from the end with the pliers, and you're still probably going to have to do some work. There we go. All right, and maybe that was too much. We might have stripped too much there. We're going to find out. Let's get those ring terminals that I was talking about. And open that bag up. Okay. And what we want to do here is we want to see if the ring terminal is going to cover all of the stripped wire, and it does. So that was roughly the perfect amount. You can always measure with the ring terminal how long it should be before you go ahead and start stripping it. That would be the smart way to do it. We got more of these to do, so that's good. All right, and now we have to crimp this. We basically have to crush this down absolutely as hard as we possibly can. So the best way to do that is, I've got a big pair of crimpers here. So there are wire crimpers. There are a variety of sizes of wire crimpers. This one, it's long. And what we've got is sort of this area in the middle. So there's like kind of like one tooth that's going to go in, and that's going to crush the wire down. But you need something with kind of the long handles. So the idea is you need that leverage to really be able to crush this down, because this is pretty big, heavy-duty wire. So if you don't have this, you might be able to get by with a smaller set of crimpers. You might be able to get by if you have a vise or something that you can really crank down and make tight. You might also be able to get away with this if you put something metal on the back. You get a hammer and a punch of some kind to hammer it in. But it's probably worth picking up a pair of these crimpers. All right, so I'm going to actually crimp twice. So there's kind of like two little sections here, and I'm going to crimp on each section just to make sure I get a really good connection. So I'm going to put that into that tooth, so that tooth is pushing down on it. I'm going to try to make sure that the insulation stays all the way in, and then really just squeeze as hard as I can. And then I'm going to move over, and I'm going to do it again in that other spot, just to make sure it's really, really crimped on. Okay. And you can see now, right, obviously we crushed it, and there are these dimples that's doing a really good job of pressing into the wire to hold it there. And if I pull on this as hard as I can, it's not budging. That's what we need to see. All right. Now, this wire is going to come off of this post here. And so to unscrew that, I think we need a 7/16 wrench or socket. I'll see if the wrench can fit in. There we go. So we can unscrew this. Okay, and then this is going to end up going on there. And we could have it going, see, this is what I mean. It can go on this way, but that crimp is so long that we're already smashing into stuff. Maybe I can bend the crimp a little bit to get it to go. I don't love that. If we come off sideways, I think it kind of works, except, or maybe on except we need to still bend back to be able to plug into there. And that feels like a lot of twisting. So I wonder if, let me undo the other side too. I wonder if we're better off doing this one on the other side. Because like this wire, if this one were coming off in this direction, that would be okay. Because then both of our wires from here would be the right length moving out to the rest of the robot. So let's see, do we like this better, right? Like, so if we're going out this way, then we can loop back. I don't really want to loop back over the top of it though, because that's where the buttons and the switches are. We could loop back along the side like this. That seems pretty reasonable. Or potentially, we could go off this side and then try to loop through them. Nah, I think I like this the best. And I think I like the idea of trying to route it down here and plug it in afterwards. So I'm going to actually go ahead and tighten this in. So let's screw this one all the way down to hold it. And if you have shorter crimps or some other kind of crimps and it works on this side and you prefer that, go for it. It will work either direction. We just have to have basically the power, the red, the positive side of our battery is going to come in through this connector. It's going to go through the switch and then, or our main fuse breaker, and then into the power distribution hub. And it can go either direction. This thing is bidirectional. It is happy to work either way. All right, so that is in there. I'm going to make sure this is nice and tight. This is another area where we talked about if you leave it loose and this connection is loose, that means that there's going to be a lot of electrical resistance in that connection. When you have a lot of electrical resistance, especially at the really high amperage, at the battery side of things, that can end up basically making your voltage available to your robot dip way down. And if it dips low enough, things will start to reset. Your RoboRio might reset, which means you can't control the robot until that's done rebooting. Or it is possible that the radio can reset or the entire robot can reset, which is going to cost you a match probably. So we want to make this tight, but the stem is built in and there is some limit. You are probably strong enough that if you really wanted to, you could tighten this so much that the stem broke off. So I'm going to tighten it till it feels, like it's there. Give it one more little tug. And one check is if you can rotate this at all. So if I hold on to the fuse here or our breaker, if I can make this rotate, it's not tight enough. But I cannot move that one at all. All right, then what we can do is I'll go around here like this. And we can sort of see, okay, we're going to need about this much wire. Right? So if that's down there, if maybe we do some zip ties or something to keep it from moving, we're going to need to cut right around here on our longer wire and then strip from there. So I'm going to mark that with my finger. I'm going to cut it with the diagonal cutters because they're a little bit beefier than the flush cutters, although you could do it with flush cutters. Probably you'd have to cut it a little bit at a time. And we're just going to maybe I can't do it with these. There we go. We didn't need the other end anyway. All right, and now we need to strip the end again on this. So whichever method worked for you the first time, you can do it again. I think I'll go back to the utility knife here. So we'll put it in, and the only difference is this time, because I attached the wire, I can't rotate the wire quite as easily. So we'll rotate both the wire and the knife here. So we go around. Let's see how we did. You can kind of start doing that like twisting and pulling, and you can see usually then where like maybe you didn't do it straight and there's still some gaps. So you can cut into those areas more. Also, if you peel it back and you still see like some plastic in there, some of that insulation you don't see all the way through to the metal, then that side is still holding on a little bit, so you got to cut that side a little bit more. But also spreading it out also makes it really easy to make sure you're in the same hole and not just cutting in a different spot entirely. All right, mine is moving. We're all the way clear. Try with some pliers again. You can go in the middle and sort of pry it off a little bit too. There we go. All right, so this one, we are going to open up the red port on our PDH, power distribution hub, the battery in port. Slide that wire all the way in and down and pull, and that seems good. All right. Now we know on the other end of this, we have to put another one of those connectors. And if we think about where we want it to end up, right, I think we thought it's probably going to have to go out this way. So the wire will be underneath this wire, maybe we'll be on top of this wire. And then that will let it come around. Okay, so in this case, you can take the nut off. This one is pre-stripped for us, but we do have to pull the little bit of insulation off of there. So put the connector on. And I'm going to look at sort of the direction that everything is bending. Also, with these connectors, I didn't mention this on the first one, but there is a flat side. And then the other side, if you run across it, right, you run into the wire. When you're putting this in here, you want the flat side to go down so the nut can fit inside the other side. That's going to make it a flatter connection onto your main breaker. All right, so this one is going to go in this way. Like I said, I think we run this other wire under it. That feels good. Yeah, so we're going to have to crimp it. And then I want these to sort of peel around this way. So that feels like a good angle. So I think I'm going to crimp it this way. And you can check yours, right? Because if I crimp it this way, then I'm going to be twisting that wire more than I probably want. It'll still work. All right, let's go ahead and get our crimp on here. And again, we're going to squeeze it in both spots. So first the higher up spot here, crush it down all the way. And then move over to the other spot, crush that one down as well, as hard as you can. Okay, now this one, before I put it in, actually, and the other one we'll probably take out now, we have to fully insulate these. So this exposed metal is going to be a problem. So it was the red bag as well. There is a roll of electrical tape. You want to use the red. So there are some wire color rules when you're doing main power or constant power. You want red to be positive and black to be negative all the time. And so we got to cover up most of this. So I'm going to start down on I'm going to start all the way up at the top edge of the connector. And we're just going to kind of go around and then start spiraling your way down. So we're going to cover over that gap and then down onto the main wire just a little bit. And You can tear electrical tape, but it stretches when you do, so sometimes you get ugly edges. It's usually nicer if you just use some scissors. Then you can finish that one up. All right, and then I did say for this one, like, we can bend this a little bit. You don't probably need to do this, but you can try to bend it up just a little bit. So when this goes down on the bolt, that's going to help direct this wire up above the other wire. All right, now I had you tighten this one in, and that's because, you know, I want you to have practice undoing it, not because I forgot that we should put the electrical tape on. So go ahead and take this one off. And then we're going to do the same electrical taping on this one. So I'm going to start up on the housing here. Kind of go around once and then start working my way down over the gap. And we'll cut it. All right. Now we're ready to reattach this one, just like we had it before. We'll get it close. And then, you know, if you have a socket, it's probably easier to tighten this than the wrench, where we're just able to do a little bit at a time, but it's okay. Make sure you're holding on to the fuse, because we still only have the one bolt holding it in place, so it will try to twist on you. All right, and we'll get it tight, give it a little bit more, check to see if we can rotate it. I cannot, so that seems good. And then we're going to go to the other one over here and get that one started. And this one is pretty hard to do with the wrench, just because everything is in the way. I think I'm close, but see how I can still move it. So let me go ahead and get a 7/16 socket here. Okay. And with the socket, it's easier because it just drops right down over the top, and we can tighten it until we're happy. All right, and now I can't rotate that anymore. And then these wires are going to work their way back across like this in order to plug into the battery. That looks good to me. I think we can live with that. Now, the other problem that you're going to run into is there are these little hats that are supposed to, you know, protect the wiring, insulate it a little bit. These hats will not pass muster at inspection. So you are going to have to add more tape to cover up all of the exposed metal here. And it's just going to be the electrical tape. I think it's hard to wrap the tape around. So if you get yourself just a little section of tape and cut that off first, then you can try to, probably with the hat off, I like to go underneath first because that's the hard part. And then just kind of bring it up and over, covering what you can. And then same thing from that side. And if it looks like everything is covered, you're good. If not, you can do more. You can do it again. Get ourselves another little strip. I think I need to get like down here especially. That seems pretty good. There might be a little bit more on the inside, but I'm going to leave mine alone there, and then we're going to do the same thing for the other terminal. Got to do our best to cover it up. This one's harder because I got the extra wire in the way too, but should be able to still fish it in there. All right, we'll kind of Take that one around. Take this one down over the top. Seems like a good start, but we're going to need at least one more piece. And you might be thinking, is this actually necessary? Probably not, but we can't take any chances with can't take too many chances with safety. So even if you have to just kind of have some strips that just run up like this, that's going to be okay. Try to get that wedge down in there, and then I'll bring it back around onto the wire. That seems pretty good. Now I think the hats don't stay on anymore because the electrical tape is there. So, you know, you could probably cut these off. They probably, you don't need them anymore, or you can just ignore them. They probably won't cause any problems either. All right. What's next? We're getting there. We're making good progress. Okay. The next thing we're going to do is in the Rev Robotics Power Distribution Hub box, go ahead and open that up. And there is a little Ziploc baggie inside. And that Ziploc bag has some fuses in it. So we're going to open that up. And there are, I think you should have 2 red fuses and some blue fuses. And they have a number on the top. So if you read the top of them, they'll tell you what amperage the fuse is for. So the little red ones are 10, and the blue ones are 15. And we need the red ones for this. So our RoboRio and our radio both have to be powered from one of these 10 amp fuses, not a 15. If you blow all of your 10 amp fuses, you could probably use a 15 amp fuse just to get things running, but you'll have to get more of these before they work. And I think these are just automotive fuses, so most auto supply stores or auto repair shops will have them. All right, so these are going to go into, if we go across from where our battery is, that corner, we got the USB-C, we got the yellow and green stuff. There are 4 ports here for fuses. One of them, the last one, says switchable, so this red one, we can't use that. We can't use the switchable one for it. So we're going to go ahead and connect. Let's connect to 20. So we're going to line up the fuse. And if you look down in the gap here, there are little metal like ovals. And we need to get the legs of the fuse, one of each of the blades of the fuse, to go into one of each of the ovals. And then you're going to push it down, and you'll know, like, it'll slide in for sure. When you're done, the plastic housing should be below the surface of the PDH. And I guess, I don't know, I'll do the other one in 22. I'll spread them out. And we'll press that down. There we go. All right, so that step is done. Let's throw the extra fuses back in the bag here. Next up, in the blue bag, you have another bag of breakers. These are auto resetting circuit breakers, Snap Action Inc. All right, there are a few different containers in this bag or sections in this bag. The first one, these are labeled 20. So if you look at them, they'll say 20 on them, 20 amp. Then 30, and then finally the littlest ones are 40 amps, are the highest power. And for the motors that we're using, we want to have 40 amp breakers. So go ahead and open up that 40 amp section and pour out all 6 of the breakers that were in there. All right, and now on our power distribution hub, we need one of these 40 amp breakers for every motor. And we know which motors we're using because the wires are plugged in for each of our SparkMaxes. So where these wires are connected here, that's number 19. I'm going to take the fuse and plug it in. Again, if you look down, there are some metal ovals. Our goal is to get this inside. If you do it on enough of an angle, you can actually be on the side of the ovals. That's not going to give you a good electrical connection. The other thing, though, is it doesn't matter whether you plug them in this way or this way. They will work the same. And it was the same with the fuses, by the way, when we plug those in. Doesn't matter which direction they're facing. All right, so we'll try to get this to go in. Sometimes these are really tight, so you got to kind of try to wiggle them a little bit and get the ends started. That one is definitely fighting. All right. So clearly, by the way, I'm kind of pushing on one end and getting it to rock in, pushing on the other end, going back and forth, pushing down as much as I can. All right, and these ones will bottom out with just a little bit of the metal still showing when you push it in all the way. So that's okay, you can stop there. Let's jump over to the other side. So we have 10, 11, and 12 with wires in it. So I'm going to add one to 10, 11, and 12 as well. Okay, this one was much easier. And now 11. Yeah, I don't know why the first one was so hard. All right, and 12. Not that these are easy. I'm still having to push pretty hard. Ooh. Okay, that one was hard again. I shouldn't have spoken up. All right, and on the other side, I used the N2, which is 8 and 9. So we'll go ahead and add fuses into 8 and 9 as well. There we go. Last one. All right. Okay, all those fuses are in. Whew. Next up, we've got, so the all the auto resetting circuit breakers are in. Our fuses are also in, but let's go back over to the fuse area. I'm gonna lift those up. We're gonna need to do stuff into these two spots. And let me keep my Rio here, just so that we don't lose track of that. I might move it again to be able to put more wires in. But the next thing we're looking for is you should have what looks like an Ethernet cable, but with a couple of extra wires sticking out of it. All right, so it looks kind of like this. Let's get it out of the bag. If I can, there we go. All right, so it has an Ethernet cable on one side, a port to plug another Ethernet cable in, and then two wires, a red and a black. So this is a PoE injector, so that's power over Ethernet. And when we plug our radio in, we're actually going to send the power through the Ethernet cable up to the radio instead of wiring additional wires up there. So a couple things. The Ethernet port on this side is going to plug into our Rio. And then those two wires, the red and black wires, are going to go into, let's do 22, port 22. So we got to get the red one in the red side, the black one in the black side. And then you can drop those levers down. And definitely give this a tug too. This is very important. If this stops working, you're going to have all kinds of problems. Let's see, that black one, maybe that went in too far. Because I don't want to be on the housing, I want to be on the wire. All right, that definitely seems good. All right, so then this wire here, I don't know, maybe we'll tuck it under this one. And then maybe it'll live down there, something like that. So then we'll have our other Ethernet cable that'll plug in here and go away. So that is powered. And now we have to power our RoboRio. So you'll need a tiny screwdriver for this. And so there are these two screws on the sides here. So at the top of the RoboRio, we've got input 7 to 16V, 45 watt max. That is the power connector for this. And we have to take it out to be able to put wires in. So on the two sides here, there are flathead screws. So you want to unscrew those two screws all the way. When they're unscrewed, they're not going to fall out. They're captive, but you'll be able to pull this connector out. And this connector has two ports here labeled V and C. So we can see up here. So one of them is V, and then the other one is C. V is for voltage in, C is for common or ground. And those wires are going to go in right next to the letters. But we have the two screws that we use to take it out. If we turn it more, so we're looking past where the V and C were, there are two more tiny screws up here. And these screws are what we're going to use to clamp down on the wires that we plug in. So you can actually, if you look inside the V or C port and you screw one of those screws in, you'll see the little spot next to it closing down, although I'm not sure. Yeah, I think we can kind of see it. Yeah, so that metal inside there will move and clamp down on the wire that we put in. So make sure those are open. Those little metal bits in here should be all the way away from the V and the C. And then we're going to need to get some more wire. So in the red bag, you're basically looking for, oh, hey, the Ethernet cable, by the way, was in the red bag, in case you're still looking for it. If not, you'll find it when you go to look for this. All right, in the red bag, we have the smallest wire. That's what we're looking for. This is, not sure what size. Looks like it's 18 gauge. And what we need to do is we need to make this wire go from that connector that we're working on over to the other fuse, that port 20 fuse. So what I'm going to do is, we could just do one side and then the other. I'm going to kind of like get myself plenty of extra wire and cut it, because I think that will make it a little bit easier to route. So I'm getting about, I don't know, what is this? This is about a foot, maybe 14 inches of wire. But I know this is way more than I need to go from where I want to plug it in to where I want to plug it in. But we'll trim it down to size later. All right, so then we'll cut these wires. All right, and then let's finish our connector first. So we need to strip the ends of these two wires. Get your wire stripper back out. And we said this was 18 gauge, huh? So I'll use the 18 gauge spot here. And we're going to strip these ones. You can strip a little bit less than we did for some of our bigger wires. So that's going to be closer to, I don't know, 3/8 of an inch maybe. Okay. And now these ends, like I said, we'll take one. We'll start with the red one. So the red one is going to go into the port labeled V. Okay, so we've got V and C here. We're going to go ahead and go into the port labeled V. And when you put it in, if you have wire sticking out, like you see I still have wire, that means I stripped too much. So I'm going to take the wire that I stripped here, and I'm going to take my clippers, and I'm not going to do this over the RoboRio or any other electronic components, because these little tiny wire ends are going to fall down after I cut it, and I don't want them in my electronics. But I'm just going to go ahead and snip a little bit off the end, roughly a little bit more than the amount that was sticking out, and then keep those little metal bits away from everything else. All right, now back to our connector. And again, we're looking for the V side for red. So we're going to slide this in. So on the side that says V, go right next to it, slide that in all the way. And then the screw right on top of the V, or right next to the V, is going to clamp down on that wire. So we're going to screw this in. And you want to get this pretty tight. Again, this is like if your RoboRio turns off, your robot stops working. All right, and then give it a tug test. Looks good. And then we'll take the black wire, and let's see if I strip too much on the black wire too. Yeah, just a tiny bit. All right, so I'm going to go ahead and do a quick trim on this wire. Cool, we're ready. All right, so now we're looking for the C, the port C on here. We're going to slide that in. And again, once it's all the way in, the screw above the C or behind the C, depends on your orientation. We'll screw that in nice and tight and give it a tug test. Looks good. Okay. So now this can plug into our RoboRio. And it only fits one way. So if you're trying to plug it in and it's not going, turn it around. Okay. Then there are the two screws on the sides next to the V and the C. So I'm going to go ahead and screw those back in until they're tight. Looks good. All right, and now we're getting close to needing to actually specifically set our RoboRio in a position. I've been putting it off, but if I put the RoboRio kind of like, in a little bit from the edge, but right on the edge of my piece of wood here, I've got a little less than an inch gap in between the two, and I'm going to leave a little, what we call a service loop. I'm going to not make this super tight. I'm going to leave just a little bit extra wire so that we can work on it if we need to, so it hops up and then comes back down. And I'm going to eyeball how far I think it's going to go into the terminal. Mark that with my thumb, and then pull it out, and that's where I'm going to snip these 2 wires. All right, and then on these 2 wire ends that we have left over, we're going to strip them again to be able to go into our power distribution hub. So this one can be a little longer than the last connector, but anywhere around there is going to be okay. That plug we're going into this time is a little bit deeper. But as always, if you plug it in and you see wire sticking out, then you know, oops, we got to try again. So I can slide my RoboRio out of the way just to get a little bit better access. And we'll go with the red one in under here, into the red port. There we go. And then we'll drop that lever down and pull on it, not going anywhere. Let's do the black wire next to it. And pull on that, not going anywhere. All right, perfect. Now, the one thing that you want to check on these ports is they are paired, right? So even though it goes black, red, black, red, black, red, make sure that you have the black and the red that is part of port 20 or part of port 19 or whatever it is. If you are off by one, then your stuff isn't going to work. So if you have one thing plugged into the red on 18 and the black on 19, that's going to be a problem. So keep an eye out for that. All right, I think there is nothing else going to be attached in here. So it is time for us to actually mount the Rio. So let's get some more of that Velcro or that hook and loop stuff. And I'm going to just realign it a little bit. So we get down to the end, it looks a little off. Okay. And we'll just sort of tip the Rio over here. And it's going to sit this way. It doesn't really matter. I'm just going to do 2 long strips, probably like here and over here. So let's go ahead and cut those down. Somewhere around here seems good. And then we want 2 the same, so I'll just cut it where the last one left off. All right. Peel one end off, stick it on the Rio. Doesn't really matter which direction you choose to take this. These slots on the side that we see here, that is for zip ties. So if we drilled holes through the woods, we could pass a zip tie through this slot and then through the wood, either back up or around in order to be able to attach this. So that is if this one feels like it's moving on you, you could try that. You could also just try throwing a third or a couple more strips of hook and loop on there as well. All right, let's peel this. And rotate it back roughly into position. And I said I want to be roughly even with the end of my thing, a little bit away from the battery wall, but making sure I have plenty of room to use one of the 2 screws, doesn't matter which one. And then we push it down. Alrighty, another thing checked off our list. What else do we have to do? We are going to have to get all of our wire ends that we're going to use coming out of our SparkMaxes. Those are going to have to get stripped and be ready to attach to our motors. And then the other thing we have to do with our motor controllers is we have to be able to control them. So we need to be able to plug them all in to our RoboRio. And we're going to do that by using CAN this year. So CAN stands for Control Area Network. And it's going to be the green and yellow wires. So basically, we're going to open up our box. Oh, this one, I kept the inside in. Weird. All right. And here's what we're going to do. We are going to take, first of all, there is this little hat piece here. And if you want to go ahead and grab that hat piece out of every box, if you can find it. If you can't find it, it's not the end of the world. But I got a bunch of these. These are basically dust covers. In this case, not really dust. It's really like electrically conductive debris covers for the top of our SparkMax. So there is a port on the top of the SparkMax. If we look maybe over at this one here, we've got this port right in the middle. And there are some wires there. We're not going to be plugging anything into that, but if you're like working on your robot, aluminum shavings might fall in there. That could short stuff out. So we can just take this hat and push it in. And we're going to do that for all 6 of our SparkMaxes. And I think it doesn't matter which way the hat is facing. I think it goes in no matter what, but we'll see. I'll try to do this one opposite the last one I did. Yeah, it definitely goes in no matter which way it's facing. So we'll cover all of those up. All right. Then the next thing is in the box, we need all of the green and yellow wires. So we're going to use all of those. And then there is another plastic clip that looks like this. We're going to need that clip from all of them as well. And then we actually won't need the USB cable for a while. Actually, we'll only ever need one USB cable. And the white and black wire that's in there is for PWM. So that's another way that we can communicate with our motor controllers. That is simpler, but not as smart. So we're not going to be able to do as many things with PWM control. Also, the wiring with CAN sometimes is a little cleaner. So with PWM, every single motor controller has to have a wire that goes all the way back to the RoboRio. With CAN, we're going to daisy chain stuff. So we're going to connect one motor controller to the one next to it, to the one next to it, to the one next to it. And only one of those wires has to make it all the way back to the RoboRio. Actually, the other end, we have to have another wire going into our power distribution hub. All right, so I've got all of those out. Now, this will be, I think, doable, but maybe a little tricky. But remember, it is Velcroed down, so if you can't get to the port, you can always pop it out. But you can definitely see the best probably on this one here. On this end, there's a USB-C port, and then next to it, next to that USB-C port, is the port that this will plug into. This, however, is directional. So there is a slot at the bottom of the port, and if you look at the plug really closely, there is like some ridges on one side. One side you can see the pins, but on the other side there are these bumps that are sticking up. Those bumps are going to have to face down when you plug this in. So I'm going to flip it over so that's facing down, and that will go right into the port next to the USB-C. Next to the USB-C. I was trying to plug it into the USB-C because I can't see what I'm doing. And you got to kind of like poke in there with your fingernail or poke on it with a screwdriver, but make sure that goes all the way in. It should sit flat when it's all the way in. All right, so we're going to do that for the other 4 that are running across here, and then the one that we have on the other side as well. Make sure they're all the way in. That one was hard to get to. That's, I'm going to poke that one with a screwdriver just to make sure it went in all the way. I can actually see right now it's not quite in on this end all the way. So that fixed it. We keep going. Same side is still sticking out. So we'll poke it in the rest of the way. Looks good. And then this one on the end I can actually reach, so that's great. And then we'll jump to the other side of our board here where we have one more controller to plug in. That one was fighting me. All right, and I'm going to poke it with the screwdriver. There we go. Okay, double check this one. Yeah, that's in all the way. All right, looks good. Now, the way that the CAN works, so like if I take 2 of the wires coming out of this one here, there are 2 wires. One is for signal to come into the controller, and then the other one is for the signal to go out of the controller to the next controller. So what's going to end up happening is we're going to take one of these, and I'm not sure which one exactly it's going to be. But one of these, we're probably going to either clip the ends or find a connector. But one of these is going to plug into the CAN port on the RoboRio. And that's what's going to send all of the motor controller commands to the motor controller so it knows when to turn on and what to do. So this one that we have here close to the thing, we're going to end up plugging one of those in to the CAN port. Then the other end, and I don't know if it really matters which side is pronged versus not pronged right now. We may get to the end and find out I did it backwards, but I'm going to go ahead and take the non-pronged side. Wait, do the prongs fit? They don't fit in the thing, right? Yeah, they don't fit. They're too short. So we're going to have to cut and strip wires, or we're going to have to find a connector anyway that goes on there. All right, so I'm going to take the side with prongs, and I'm going to connect it now to the first of our speed controllers on our line of 4 here. Do I want to do that? Is that really what I want to do? Because we got to get this one connected as well. Let's see. Yeah. You know what we're going to do? Forget what I said. All right, so this first horizontal one, or vertical one, depending on your orientation, one end goes into the CAN port. The other end is going to go to not the front one, but the farthest speed controller back here. That's where we're going to go next. So I'm going to take the plug on that one that is not pins. I'm going to make sure the yellow wire lines up when we plug it in. So the connectors are going to be rotated, but we're going to have yellow wire to yellow wire and green wire to green wire. And now this connection is really bad on robots. It doesn't take a lot for that to unplug. So that's what our other plastic clips are for. So these plastic clips here, what you do is you push them up from the side, and the connector will snap in there. And now it can't unplug. That clip is going to stop it from unplugging. So we absolutely need those. All right, so that was step 1. Let me see if I can organize these a little so it's not crazy when we go. Okay, so we went from this one to the far back one. Now that far back one, we have the pin side coming out. We're going to go to the one right next to it, the non-pin side. Same process. We're going to get yellow wire to yellow wire, like that. And then once again, we're going to get one of those clips and pop it on so it cannot fall off. Looks good. All right, then the other wire coming out of that same SparkMax, the second one on the line, that's the side that has pins. We're going to go to the next one on the line, get the wire that doesn't have pins, yellow to yellow, and put a clip on it. Okay, then the next one coming out of that speed controller is the one that has pins. We're going to go to the very first one now, the one that does not have pins, yellow to yellow. Basically, we're doing exactly the same thing. All right, and get a clip on that one. There we go. Cool. And now the last wire there is lined up to go across everything to plug into our speed controller on the other side. So this is the pinned one coming out of our 5th one on the one side. So we're going to use the non-pinned one, yellow to yellow, plug it in, and get the connector on it to branch across to the other side. Perfect. Okay. And we could go through. You might end up disconnecting this. In fact, I'm going to disconnect it. So we're going to, and that's good practice for you anyway, so you got to kind of just peel it apart, and you can sort of pull the connector back out. I want this connector here to go underneath all of these other wires. So I'm going to pull it through so I can sit down close to the board. And then, once again, I'm going to find my last one in this column, because I have 2 wires here. It's going to be the one with pins, and that is going to plug into the one without pins. Yellow to yellow, and then get that clip back on. And I'm just thinking about like how this wire is going to route. Like I want most of this wire to sit down here towards the bottom. And then, you know, all of this extra stuff we're probably going to zip tie. We're going to probably bundle this up and zip tie it down so it stays out of the way. But it seems nicer to have this down underneath stuff protected instead of on top where it could get caught in things. Okay, and then we have 2 ends left. One end has to go into the RoboRio. One end has to go into the power distribution hub. Now, there's a couple of things that we can do here. The first thing is, let me grab, it's actually either of these. So in the, I mean, I think they kind of work the same. All right, so in the Molex box for CAN bus kit, we have some wires that we could use for this. So if I open one up, Probably not that one. Maybe that one. All right, so some of these are female and some are male ends, which means some have pins and some don't. So this one has the pins sticking out. So what I could do is I could take the pins that are sticking out, I could line up yellow to yellow and push this on there and plug it in. Now I have two bare ends of wire that I could put into the CAN port. So you could do it this way. If it adds one more point of failure, and because this cable coming off of the SparkMax does not have a clip, this is designed to have two pieces that clip together, this could pull apart. So I would probably add electrical tape if you're going to do it this way. This adds a little bit of extra complexity, but it does mean that you don't end up cutting the connector on your SparkMax, which may or may not help you in the future. I don't know. Then the other end, where it's two pins, the other bag has the other side that would connect to that. So again, it would be yellow to yellow, but you can see, again, this one especially, there's nothing stopping this from falling apart. This one's really easy to come apart. So that is the other option to do it here. I think what I'm going to do with these is I'm going to actually just clip these wires and strip them and put them directly in, because I think that's going to be more reliable. And there are ways to add connectors back on the end in the future if I have to. Also, you'll probably get some more SparkMaxes next year. And you might have to have one that has the end stripped next year if you reuse it anyway, because something's got to go into the CAN bus. Now, there is a halfway solution that you could do, which is if I take one of these wires and I clip the ends about this far, we would have bare wires on that. And it could plug into the other one, and I could use those bare wires on the other side. So I could clip this and not clip the other one and still have a nice short set of wires to plug in there. But like I said, I'm going to clip both of them because I still think even just this connection, right? If you do this, that's fine, but make sure you tape this together because it is just way too easy for it to fall apart. All right, so this wire is going to go in. I'm going to leave, like I said, enough just for this connector to be useful in the future if I decide I need to use it. But I'm going to make sure that I have plenty of extra wire to get into the port that I'm using. So I'm going to leave about maybe an inch of cable on there. And I'm going to cut it, and there's no going back. All right, and then this one on the other side, kind of the same thing. I'm going to do about an inch of cable just so I could use it in the future if I need this kind of connector. And it is done. All right, so now we're going to untwist a bit of the wire. Don't untwist more than you need to, but untwist enough that we can strip the wire. And I'm going to do this one first. So now that I have them both untwisted, since I'm holding this one, I'm going to do this side. This side is going to go into our power distribution hub. So let me get the wire strippers. This is probably 18 gauge wire, maybe 20. I don't think it's 24. It feels bigger than 24. All right, I think I want just a little bit more stripped. So the 20 gauge wire spot worked for me to strip the wire. So. And just a tiny bit more. All right, that looks good. All right, and so you can choose down here on the power distribution hub. We have red, yellow, and you can use whichever one you want, as long as you use two that are next to each other. So I'm going to use the bottom two, the closer two. Lift it up, and make sure yellow goes into the yellow spot. And green goes into green. Since these are twisted together, I'm going to try to put both of them in at the same time. If it works for you, great. If you have to do them one at a time and untwist a little bit more wire, that is also fine. I might have to do that. All right, let's try one more time before we give up. Okay, they're both in. I'm going to lower them down. Tug on each wire. Don't just tug on both of them. Make sure you pull on each one to make sure it's not moving. And that seems pretty good. All right, then on the other side, we have our other two ends that we clipped. We're going to strip those. Okay. And these connectors work a little bit differently. If you're lucky, you can just take the wire and push it straight in. So one's labeled L green. You can sometimes just push the wire in. And if you push it in as far as it'll go, then you can tug on it and it doesn't come back out. That doesn't always work. Sometimes the wire is too flexible and it bends on me. And so you can't do it that way. If that way works, great. If not, what you can do is you can push down on this little white button that's next to it. And if you push down on that button, that opens up the spot for it. There's like a spring clip that's holding stuff in place. Then you can push this down and then let go of the button. And again, give it that tug test. Which, by the way, if you need to take these wires out, you just push down on the button, and then the wire will come out. All right, but we'll go back in, let go, tug, tug, looks good. All right, so close to finished. Looks like we have one extra clip because we didn't use that last end. So I'll save that. That might come in handy in the future. All right, so all of this. Let's run through the CAN bus one more time, what's happening, just to make sure I've explained it. So signal is going to come out of the RoboRio. Actually, they're all communicating. They're all talking to each other. They'll talk back to the RoboRio will talk to them. But we need this daisy chain. So this is going to go out to our first controller. That controller is going to go to the next controller, 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 and then finally to our power distribution hub. This is the last device. Now, we have this chain of wire with the RoboRio on one end and the Rev hub, power distribution hub, on the other end. The way that CAN works is on each end, there's a resistor called a terminating resistor that lets the signal kind of know that this is the end of that chain. So there is one built in to the RoboRio that you can't turn off. But on the power distribution hub, there actually is a little switch here. You'll see it right next to the yellow and green section, and it's labeled term. And there's a switch for on and off. Just make sure that stays on. We want that terminating resistor on that end. OK, that is it for the CAN bus. All right, the only thing we have left to do is to strip and prep these wires to be able to connect to all of the motors once we put it back inside the robot. So what we want to do now is, first of all of the white wires we are not using. If you use a brushless motor, if you ever upgrade one of these to a brushless motor, then you will need the white wires plugged in. And there's actually a sensor port that you're also going to have to plug in. But the sim motors that we're using are brushed motors, so they just need voltage going to them. They don't need this extra third line. So all these white wires we're not really going to use. So at some point, definitely don't strip any of those when we go to prep our stuff here. But at some point, we'll probably zip tie these underneath here just to keep them out of the way. Maybe something like that. I don't know exactly. All right, and we might wait until it's in the robot because then we'll have a better idea. I do think we should do something with all of this bundle of CAN wire. So I think in the Molex Blue Box sample kit, I think if you dig down, there is some little tiny zip ties, which are going to be great for this. There actually are also zip tie anchors, which are these little adhesive squares. We might use those later, but you can put the anchor down onto something and then zip tie it down to it so it doesn't move. But I think in this case, I'm just going to get a couple of these tiny zip ties. And I'm going to do my best to get all of these wires and line them up. And some might say that we shouldn't do this yet because when we go to troubleshoot, when we plug everything in and test it, we probably are just going to have to clip these zip ties. But I don't know. I want it neater before we move on. So I'm just going to go ahead and grab one zip tie around this end to get a little bundle going. And then probably the other end doesn't need it, but I'll go ahead and do one more bundle on the other end as well, just to hold everything together. Okay. And then there's some more things we can do. Like if we're worried about any of these wires getting caught up on stuff, what we can do is we could take these down and maybe zip tie them to these power wires. The power wires are much more sturdy, can take some pulling on versus our signal wires. So if we kind of piggyback on there, that'll help protect those wires. And we could do the same thing on this side. This wire is so short, it's probably not a big deal, but we could do a little bit of strain relief on here if you were worried about it. I'm gonna just let that one go. All right, now I'm gonna put this back in the blue box so I know where to find it later. Inside the blue bag, you will find packages of Wago lever nuts. These are great. These are my favorite. We need, there's 10 in a package, and we have 6 motors. We need 2 of these right now, I think. Might be all we need total. We'll find out. All right, so I'm going to rip this open. And these are going to look real familiar because there are orange levers. And if I lift the lever, I can put a wire in. When I lower the lever, it locks the wire in place, just like is on our board back here. Literally the same. I think they're the same brand. I think they're the same company that makes. Yeah, in fact, I can see on the power distribution hub here, it says Wago. So they work the same way as what we've been working with. So nothing is going to change. I think also on the side, if you look at the side of it, there is some writing on one side, and there is an 11, a number 11, and some arrows on this side here. That is actually, I think, the gauge that shows you how much wire you should strip. So if you look at that, you can eyeball it to that. It doesn't have to be perfect. You can definitely be more or less. But that's what we're aiming for, is the length of those 2 arrows. All right, let's start stripping all the wires. I guess we'll strip all the wires first, and then we'll put Wago connectors on all of them. If you have extra people working, right, like you got another team member, one person can go around stripping, the other person can put the connectors on. We're only doing red and black wires that are coming out of our SparkMaxes. So let's get going. 1, 2, and 3, and 4. Oof. That one was a little rough. All right, that was 5, 6, 7, 8. Feel like the count now? 9 wires. All right, 10. Incidentally, I'm counting just to make sure I don't miss any. I know there should be 6 speed controllers, 2 wires per speed controller, so we should get to 12. 11, and finally 12. Right now we're going to go through with the Wago connectors. And basically, we're going to slide the wire on, slide it right into the connector. And you might have to push a little bit because the insulation gets a little stuck. So make sure you really push to get that insulation to go inside, and then close it, and then tug on it. And then repeat that 11 more times. Tug, it's good. Tug, it's good. It's good. This one is good. Okay, and if you put it in, this time I had one wire that bent back when I put it in. If you get that and it's just one wire and it's not really visible on the outside, it's okay. But if you see any wires coming out of the housing, that is a potential place where it could short out. So you don't want that. So you got to take it out and try again. That's where you can twist it up a little bit if you need to. All right, so close, so close. Okay, next to here. And we need 2 more from the second bag on the other side. Tug it. And tug. Okay, that is all of those pieces done. Mounted, mounted, mounted. There is, I think, one last thing I want to do with this electrical board before we are done here and ready to put it into the robot. Two last things I want to do here. I'm going to clip the zip tie ends because I'm here and looking at it. All right, and then the last thing we're going to do is on our RoboRio, I'm actually going to get, we used the red electrical tape before. I'm going to go back to the red bag back here, and there is a roll of black electrical tape as well. And what we're going to do is we have plugged in everything that needs to be plugged in on this robot except for the RSL, or robot signal light here. What we don't want is any aluminum shavings. Like when we go to put this in the robot, if we have to do more work on the robot later, we don't want like aluminum shavings to get in any of these pins. So what I'm going to do is I'm just going to take some electrical tape and we're going to tape over all of these ports, except, again, for this one here that's labeled RSL down here in the bottom corner. So we'll get a strip of this that can kind of go across all of that. Also, don't cover up the lights. The lights are important for debugging and troubleshooting. Okay. I cut that one. Wait. Okay, so we just cover that all up. The one in the middle. And I guess you could use red electrical tape for this too if you prefer, or if you have other colors of electrical tape. They would all work fine. Just feel like the black blends in better with the RoboRio. All right, we're going to do this section, so to about there. And then down the other side, and this could all be one piece. We don't have to cover them up separately. Oh, I left that one way short. All right. We can stack it up then. All right. And then one more tiny one, SPI up here in the corner. I haven't run into problems with the USB ports, but you could cover those up too, in theory. This USB port, though, the square one, we're going to use that potentially. We need to use the SD card port later. So I'm going to do this little SPI port up here and then call it good. All right, I got to clean up my mess here. This table is covered in all kinds of stuff. So I'm going to get this all cleaned up. We're going to bring the robot back in. We're going to get the electrical board mounted back in the robot, and then we're going to wire up all the motors and the robot signal light and the radio on the robot. So we'll be back in a sec. All right, back with the robot. Let's get our electrical board mounted back in. Actually, before I slide this in, I'm going to do one thing, which is, so this board is going to go in, again, this way. We have one Spark on this side, SparkMax speed controller on this side, which I think we'll use for the motor that's up on this side. And then we have 5 on the other side. So I'm going to send all 4, this row of 4 here, I think, I'm going to do that as my 4 drivetrain motors. So before I put this in, while we have a little bit more access, I'm going to try to feed all of the wires from these motors kind of up and out to the left side of the right side of the left side of the robot. This side of the side of the robot that has the 4 SparkMaxes. If we don't do this, we can probably still fish them out later, but this might save us a little bit of effort. All right. So those are all out where I can grab them. All right. And now let's feed this in. Oh, that's not helping. All right, let's get that around. I think the biggest challenge is getting around the tab on the battery mount here. And once we're past that, it's kind of working. All right, and what am I stuck on? There we go. Okay, and I saved the hardware. So we can do the one on the front. If we get it to line up, it's somewhere around here. There we go. So we can do the one on the front because that one didn't have any washers, and then we'll have to come back and add our washers on the sides. So I think last time I reached through here, to get to it, let's get the one's right on the edge, always banging into the hopper here, but it's going. You're almost there. All right, that one is in. Next up, we can do the side here. It's going to be 3 washers and 3 washers. And just doing my best to line the washers up. There we go. And these ones are pretty accessible, so they're easier than the last one. Again, that front bolt, when you're putting it in and out, it might help to take the robot off the edge of the table or flip it on its side to get access to the bottom of that one. These ones, though, are really easy. Once you get the washer stack in place anyway. All right, that side's good. And then we're on to our last side here. And we just got to line the washers up again. Those ones went a little too far. There we go. 1, 2, and I dropped one, so I'll get a new one. And 3. second one. Okay, now we can check a few things now that we're in this position. The first one is, remember that button to turn off the robot. I said I wanted it close to the edge, but not necessarily underneath, because I was worried if we put it underneath, the inspectors might not like it. So you can see if I drop the wrench down from the side here, we are just on the outside of that box, about a wrench's width out. So it's going to be easy for us to press the button, but crucially, I think it's going to be really hard for a ball to hit it, right? So if the ball is against the hopper, it can't get to that button. So it's going to be a lot harder for that button to accidentally get pressed. And then it's still really easy for me to reach on the inside to turn it on and off. All right, that one looks good. And then the other thing that we were checking was the wires that were going to come across here for our battery. And that also looks like it's going to be in a pretty good shape underneath the floor here. And our battery will be able to join it, and we'll plug in somewhere under there. That stays underneath the hopper, doesn't stick outside of the robot, which is what we want to avoid. So that looks pretty good. I think that's going to work. All right, so next step is, let me give myself a little more room here. Let's work on this side again. And we've got all of our drivetrain wires coming out here. So this whole bundle is for our drive. And we want to make sure that we can keep track of which wire is going where. I think what we can do, if you have some tape, and like masking tape will work, any kind of tape that we can write on will work, we can sort of label things as we go, just so that when we come back and program this robot, we know whatever, like that this one was a left drive and a right drive and whatever everything is going to be. So we want that. We're also going to need wire strippers. And then I'm going to go back into that blue Molex box, and I'm going to get the zip tie anchors and the zip ties. And I'll also grab my other zip ties that I have back here. I think I have some, we'll just stick with the way too long ones because that's mostly what I have. All right. And interesting, one of my Wago connectors fell off, and this was on one of the pieces of wire that did not strip super nicely for me. Let's go ahead and put that back on. Pretty sure I pulled on that, but maybe it got caught when I was putting it into the robot, and that's how it came free. So that's definitely on there now. Okay. So what we need to do is we need to basically take this bundle of wires that we have coming from our drive. And if you need to take the robot apart to be able to figure out which is which, that's OK. But I think I can see where the wires are going. So the two longer ones, of course, and those are separate. These are going to be the two motors on this side of the robot. So again, if the intake is on the front, this would be the left. But again, if you were lining up to launch, this would then be the right. So kind of hard to say 100% which side it is, but since we've been saying the front is where you intake, then the motors on this side are going to be left side motors. All right, and so I have those two bundles. Oh, I mixed them up a little bit. All right, I have those two bundles here. I want to make sure that I don't mix the wires up. So right now, this is one motor, this is another motor. You should definitely double check that and make sure that that is the case, because if you do split them and like mix the red and the black from opposite motors, weird things are going to happen. And so for right now, I'm going to just add just a little bit of tape onto here. That will hold the two wires together. And then we could also throw a label on this if we wanted to. All right, so this is like on the left side. So this is going to be left drive. And this will be, let's say, motor number 1. So I can put like LD1 on there. And let's do the same thing for the other set of wires. I made that one much bigger. All right. We call this one LD2. And then for the wires that are coming all the way across the robot here, uh-oh, almost lost one. There it is. So I think if I tipped the robot on its side, it would be much easier to see. But here are two motors that go together, and then this is the other two motors that go together. So we'll get a bit of tape on there to hold it. I think the biggest thing with wiring is it takes time, it's slow, but you want to be as precise as you can be, because any mistakes here take a lot more time to troubleshoot than just not making that mistake in the first place. So this is going to be right drive 1, and this is going to be right drive 2. Okay, then we can kind of do the same thing on our SparkMaxes. So let's see if we, of this size, I think, can get a couple, I guess by a couple I mean exactly 4 labels ready to go, and I can have them match. So what we can do, left drive 1, left drive 2, right drive 1, and right drive 2. That's the worst 2 I've ever written. All right. And then we can choose what order we want them to go in. I think that, does it matter? Like all of these wires will reach everything. So it really doesn't matter. I'm going to do, I'm going to start in the front here, or in the back of the robot. I'm going to make that be left drive 1, because the left drive is on this side, so in theory they're a little bit longer, so they can reach the wires that are a little bit farther away. So I'll start with my back SparkMax and label that left drive 1. Then the next one I'll label left drive 2. Don't cover up the LEDs. There are a couple spots. There's a LED and a reset switch button, but definitely don't cover the LED. We're going to need access to that LED later. All right, then the next one be right. And right 1, and then the last one here will be right 2. And I don't know if I can reach it because of the hopper, but we'll do our best. I wonder if I can push it down through the hopper. No. All right, so we'll sneak a finger in there somehow. All right. Okay, and if you need to take this out to relabel it, that's fine. Definitely, if you watched all the way through, you could label it before putting it in. And the other thing, too, is like the hopper is only really held in by zip ties. So if we had to cut some of these zip ties, we'd be able to bend this plastic piece up a lot more to get out of our way. But the one floor, the main floor in here, is bolted to the metal ramp, so that one's not going to move too easily. All right, so let's take our left drive 1 and the wires coming out of left drive 1. And we're just going to open the other side of the Wago connector. And you want to slide in the matching color wire. So we'll do the black wires together and give it a solid tug all the way through, and then the red wires together. Now, in this case, you could actually flip these wires, and it would be fine. These wires are on the output side of the motor controller. And actually, when we tell the motor to run forward or backwards, what the speed controller is doing is it's actually flipping the wires internally to be able to switch the voltage, or the voltage polarity. So if you end up having a motor that's running the wrong direction, you could flip these wires to fix it. It's going to be better to fix it in programming, and that's what we're going to do if we run into that problem. But just know that it won't hurt anything if they're flipped here. It'll just run backwards. Whereas on the other side of this, speed controller. If we flip the wires, that would mean the source voltage for it would be coming in backwards, and that would be worse. Okay, next up, I'm moving on to my second one here. Just kind of get that wire a little bit out of the way. All right, so the second one coming out, that's LD2. I've got the wires that I labeled LD2, and we're going to do the same thing. Red wire to the red wire. Make sure all the strands get inside. And tug. Black wire to the black wire. And tug. Good. Okay, kind of shove all of those off to the side for now. Next one is RD1, which I've got as this one here. And it doesn't matter which of your motors in the transmission is 1 and 2. Again, they're going to get the same signal when we drive. And they should, in theory, be facing the same way and working the same way. So it doesn't matter which one's which. If you really want to be consistent, you could maybe have like the front motors always be number 1 and the back motors always be number 2. But again, especially if they're labeled, we're not going to have any issue with them being mixed up. All right, and tug those. Cool. Shift that one off to the side, and then finally, right drive 2. Looks good. And the last wire. All right. Now, all of these wires, we are eventually going to have to flip the robot over and figure out where we want all of this excess wire to be. Let's see. Let's think about it. There is an argument that could be made for keeping all of our connectors up here and adding something or finding something to zip tie them to here, because then they are accessible. I definitely don't want to take all of the excess and have it be way out on the edge of the robot. I want to keep things in a little bit tighter so that it is protected really from other robots and things that might hit them and cause problems. But I do think, yeah, if we take the 2 right drive ones here and make a little stack, and then we take the left drive ones and we make a little stack on top of that. Seems like reasonable to try to add some zip ties holding that down. See, I guess we want these enough. Yeah, that is definitely out of the way of the motor. It's out of the way of the wheels. Then what we'll do is we'll pull the rest through and we'll find somewhere underneath to zip tie the rest of those up. So this seems pretty good. Is there an easy thing to zip tie to that we have here? And I think not really. So we have a couple options. We can try to use the zip tie anchors, but I think I'm going to want to save these for the side of the hopper when we have to run those other wires down. We probably have enough. Though sometimes with the zip tie anchors, just because it's adhesive, it's like glued down, it's taped down. When you have big, heavy wires like this, it can end up breaking it free. So let's go ahead and if we drill a couple holes here, that will give us a place to zip tie to. So I'm looking down to make sure I hopefully don't hit the frame, but I think I can drill a hole right there and right, say, here. That won't hit the wheels either, and that will give us one spot where we can zip tie things. And then on the back edge, if I go kind of like here and here, that one needs to be in a little bit more. So I'm going to go to the front of that. So if I drill 4 holes in those places, then we can fish zip ties down and around and hold it down, and that's going to be more secure than the anchors. And so again, for this big, heavy bundle of wires, I think it's worth it for us to drill those holes. Let's see if we can do it. I think we can do it without taking anything apart. So let's grab the drill. And for this one, you can probably use a 1/4-inch drill bit. The hole can be a little bit too big. That's not going to really cause any problems. But if you have your number 7 drill bit as well, probably works. It's really just whatever size your zip ties are going to fit through. So we'll get this chucked up. And we might have to drill a little bit on an angle for the inside one. That's going to be kind of okay, or I'll shift it over a little bit till I can just fit it. And we're just going to drill through the wood. And I went slowly. If you hit the metal of the frame, you probably want to stop and try to shift it over a little bit. I think I was just catching the edge of the metal when I stopped, but let's see. That zip tie. Oh, I see. Also, you have to be very careful when you're drilling these holes because the belt is under there. So when you're drilling in, when you get to the bottom of the plate, you've got to stop. Don't keep drilling. So go very slowly. This one is going to be clear. There's no belt underneath. Always look underneath where you're drilling. But this one is fine. There's nothing there. Okay, and then this next inside one is, again, I can see where the edge of my frame is, and I can kind of see the belt around the corner. So I'm going to drill this one down and hopefully not go too far. The other thing you can do, which is probably not a bad idea, if you take a scrap piece of wood or something and feed it up underneath there, or a piece of aluminum, you can block the bottom. So when you drill through, you end up hitting that piece of wood instead of whatever's underneath it. But there we go. OK. Now we'll get a couple of these zip ties. And I like to prep them with the wires out of the way first, just because it's easier. So this is going to be a little tricky because we have to feed it down, and then we have to feed it back up through. And so sometimes if you kind of add a little bit of a hook to the end of the zip tie, kind of bend it around in a circle like that, that can help out a little bit. So when I get this through, it's sort of already going up towards the hole, where hopefully my finger can reach and help it go the rest of the way. Let's pull it through a lot. And try to aim again. Yeah, this is a really rough spot. So again, if you want to try the zip tie anchors, that is also reasonable, especially given how hard it is to line this up with the hole. Oh man, it was right there. All right, one more try. There we go. Don't start it though, because we gotta move the wires around. All right, and then we got this one as well. I think this one should be a little easier because I can reach out from the bottom. And if you can only get one of these, that's still probably good enough. All right, now let's go ahead and bring this all back over to roughly where we wanted it. Again, I'm going to try to keep 2 layers here, left side on top, and then the right side pair on the bottom. Something like that. And this one, make sure I get around all the wires here. Something like that. So that's not going to move around much. Then we said we're going to get these wires down here. Right, we'll pull those in and we'll find some place to anchor them on the inside. Then we have all of the white wires that can definitely get into our drivetrain. So that is something we need to solve. And you can do this in a couple different ways. One is you could probably put a zip tie anchor down and attach them to that. Or you could probably zip tie them to the wires that we have already zip tied. I guess let's do a zip tie anchor just to get an example of how that would work, but it would be totally fine to zip tie these right to the bundle that we already have secured. So we'll take one of these, peel it off, and kind of make sure that area is clean. I'll zip tie them down right around here and push it down securely. Now, you have to be careful. If you rip this off soon, the glue might not have fully cured that's holding it down. So a lot of times when you do this, the first time you pull on the zip tie, it pops free. But after that, it gets a little bit sturdier. So if you don't rip it off when you're assembling it here, then you're probably going to be good. So I'm just going to take all 4 of these wires. I have them sort of like these 2 are going to the front, and these 2 are curving around to the back. So they kind of crisscross each other. And the zip tie is roughly in the middle of where they're going to be. So I'm going to feed the zip tie through. It's hard to see that in there, but essentially there are, on the zip tie anchor, there are slots on the side. You feed the zip tie through like this, and then you can just go ahead and loop it around and tighten, and that'll pull it down into the little sticker. So I'm through the gap on the bottom here, so I just have to tighten this. And I'll get it going a little bit, make sure all the wires are still in there. They are. So then I'll pull it tight. And remember, I'm not going to just yank on this end right now, because that'll rip the anchor off of the wood. So if I'm pulling down on the wires, though, then I can pull a little bit to tighten it. And that looks pretty good. All right, let's trim some zip tie ends here as we go. OK, so remember, we do have this issue where we're going to have to pull these wires back and find another anchor point, just so that we're sure they don't get into the wheel here. And then let's see if we can reach it. We've got our other SparkMax here in the middle. Let me see if I can get those wires to pop out on the side here. I just barely can, I think, if I go up on the top here. So they're right underneath the edge, which is going to be a little bit of an issue. OK. So we have these 2 wires from the top of our robot. So this is the set that is driving, the launching wheel, as well as the front intake, and not the feed wheel one. But it's just the motor that's on this side. We need to get these wires down to those connectors. And I think we need to kind of take our time and make sure it's not getting somewhere where it's going to be in the way or be getting stuck to stuff. So the first thing I think is this wire or this churro piece is right here. Let me go this way to the churro piece, I think. So I'm going to go straight from the wire kind of down to the churro piece. And I'm just going to zip tie it right to that churro as sort of like the initial anchor. Again, I hope your zip ties are shorter. These are way longer than I need them to be. And let's just get that in there tight. And I'm trying to keep the end of the zip tie sort of towards the motor, because then it won't interfere with any balls that maybe are stacked up there. And we're going to run these to the edge here, to the side of the frame. Then we're going to have to go up over the frame and down. I think I want to actually run it up over the frame, though, where it's plastic, in order to not have a problem. Or alternatively, we could put a hole. How worried are we about stuff hitting the top here and damaging the wires? You know what? I think I'm actually worried about that. Because if you ever flip the robot over and put it down on this temporarily, even though this isn't the strongest structure, that would sit on the wires, where they're, especially if they're on the metal, where it might cut them. If you ever crash into anything that's on top here, that would also be bad for the wires. So we could maybe come to this hole, but then we'd have to go back through all the gears. I think our best bet is to really just drill a hole around here in our plastic panel, and then we can use that to feed the wires through. And I think we might be able to get both wires through the 1/4-inch drill bit that I've already got. So let's just kind of eyeball where we want it to be. It looks like I want it to be really close to the hole that's already there, just in a little bit, or above it a little bit, or Looks like below doesn't work because the churro is right here. And, well, I guess we could go around to the bottom of the churro. Okay. The moral of the story is it doesn't matter too much where you put the hole. Somewhere around the end of this churro bolt. So I'm just going to go next to the hole here. And I'm just eyeballing it. I'm just going in a little bit so there's some clearance. And because this is for wires, even though that's plastic, I'm going to get a deburring tool. I don't want sharp edges anywhere where wires might run. So we'll go ahead and hit that with the deburring tool on the inside and outside. Okay. And we can try now, do both wires fit through that size hole? I was wrong, they don't. All right, let's jump it up to a bigger size. I'm going to grab let's try 3/8 drill bit. So swap over to that size. All right, and I'll just go right through the hole that's already there. Okay, if yours was too close to the edge to go up to a bigger size drill bit, it's just drill up above instead, or even farther below, and then that's going to be fine. We just don't want to go through the sidewall here of it. So I think this is going to be okay. This one left a lot of burrs on there, so we're going to work on getting those deburred out. And the inside is pretty bad too. I think the inside edge here I can get better by tilting it down. Okay, that seems pretty good. All right, now both of our wires will in fact fit through the hole. And do they actually make it to the connectors without needing more wires? You know what? I think they do. All right, that's great. So we want to take a pretty direct path here down around to where we're going to put these wires. So we can kind of visualize that path. And I think what we want to do is we're going to connect these first. We're going to plug them in first, and then we'll add zip tie anchors to hold them out of trouble. Because I think we want most of the wire to be connected. And then what we can do is we can pull the path, right? Like if we needed to go as far as possible, we can go in a diagonal. But if we have a little bit of extra wire, we can pull it off to the side a little bit. And that would use up that extra wire. We could go straight down and then over. And that would use up that extra wire. So let's strip the ends of these two wires. And these should be 12 gauge. Looks good. All right, and now this is a little tricky. So those two ends that we have here, we need those to somehow come far enough out that we can open them up and pop the other wires in. All right. So I think there's just enough room for me to do that. So I'm going to lift up. There we go. So that is the black one. We'll feed the black wire in. Close it down, tug on it. That one looks good. And then the red wire is the closer one, so that one actually sticks out just a little bit more. And we'll be able to feed that wire in and snap it down. All right. And again, like we don't want to go straight down like this and then have this extra bit of wire that's kind of dangling towards the wheels. So I think that, what do I like? I think I like kind of going maybe in a path like this. So they're a little bit farther forward when we attach them in. So let's get some zip tie anchors. First one, I want to keep it away from the gears too, so we'll go on a little bit of a diagonal, somewhere around here maybe. Okay. And then we'll do one more, sort of where we have them turned. And this turning also is going to help direct the wires to stay underneath instead of coming back out. So somewhere around there. And you can control the direction, right? When you put the anchor down, the zip tie is going to go either the direction it's facing or 90 degrees to the direction it's facing. So if I want this on a little bit of an angle, I will put it so that one set of those openings are going along that direction. And then I'll use the perpendicular side to control the angle of the wires. And we'll pull that tight. That looks good. Those are not getting into any trouble. We could potentially add another zip tie somewhere on the other end if we were worried about it still moving around. But I think that puts us in pretty good shape. Let's check the top as well. Like, I'm not super worried. You might want, we did the one zip tie on the churro bar here. You might add a second zip tie over by the hole if you need to, or if you feel like that would help out. Would give an extra support. Mine is sitting nice and flat, so it's probably OK for now, but I keep an eye on it. And let's go ahead and trim all of these zip tie ends as we go. All right, so that is 5 of our 6 motors hooked up. Let's kind of make some space here. We did not label that one, that speed controller. So let's go ahead and do that. Because I know it might be a little bit before, somebody gets to programming. So we'll do 2 more of these little tags. And add a pen. There it is. All right. So we have this motor here. This one is the one that just does the feed. And the other one is intake plus launcher. So this is going to be, we'll label one the feed motor. So I'll do feed. And the other one is going to be, I'll do intake plus launcher, I plus L. But whatever label makes you happy. So the feed one is going to be the one that's easy to access over here by our power switch, by our main breaker. And then the I plus L one is going to be the one that is almost impossible to reach. Oh, no, this is not too bad. Underneath here. I can get it to start sticking, and then I think we're good. Yeah, there we go. All right, perfect. OK, now, on this side of the robot, we have to do kind of the same thing. We're going to have to route these wires out. And again, I think I don't like, oh, look, and I found a broken zip tie up here. We'll fix that while we're at it. All right, we need to route these wires kind of the same path, right, to get down to here. But in this case, oh man, actually, if we drill a hole, or even if we don't drill a hole, I think we don't need to extend wires. I think they're going to just reach. So I will show you what to do if yours are a little bit farther away, because I know we kind of place the speed controllers on our electrical panel by feel instead of having hard and fast measurements. So I will show you how to extend these wires if you need to. But then I think I got lucky, and I'm not going to have to do that. So let's grab a couple of these zip ties. First step is going to be, well, my first step is going to be to fix this broken one on the top here. Had like more broken zip ties than I would expect. I wonder if I got not the highest quality bag of zip ties here. All right, that one is back. Next up, I'm going to do another zip tie, holding right on that churro bar, just like we did before. And I'm going to stay to the inside here. So I'm going to pull the wires up inside of the churro, just because it makes me feel a little bit better. And then we'll go right down onto that churro bar, just like we did on the other side. So get that zip down. Okay, that's good. And then you sort of have the same option. If you want another zip tie towards the end, you can. But I think we need to add a hole. I think I would rather add the hole again before we drill through here. So I'm just going to go off from the churro bolt a little bit, making sure not to hit the other zip tie that's there. And I'm going to use that 3/8 drill bit because that worked on the other side. right. And you can see we got it on the gear here. You definitely want to take a second to make sure that we get the bits off the gear. Because if those bits are getting in between the gear teeth when we go to drive it, it's going to add some extra friction. Now, because it's soft plastic that we're putting in there, and those gears are metal, they will smash the plastic out of the way, and it's not going to be a disaster. But I'll kind of do a spin around here. Actually, before I spend too much time on that, let's deburr this hole, because we're going to throw a little bit more plastic chunks down onto our gear there. All right, and we'll get the inside too. Okay. Now I think I will do one full spin of this wheel, kind of just like, I'm using the zip tie end because that reaches in between the teeth pretty nicely, and I'm just kind of, if I see a bit of plastic, I'm just going to push it out of there or drag it out of there, especially this one. That was a big piece. A couple small pieces here, probably doesn't matter. And you can also tell as you spin it all the way around, if you feel it getting bound up on something, back it up a little bit and see if there's a plastic piece there, but that seems fine. That's spinning, no problems. So let's feed our wires through the hole. All right, and then, again, if these were up like this, I actually have too much wire in my case. So there's a really good chance no matter where you put this, it was going to fit. But let's go through the same process. So we're going to strip the ends of these. Again, those are 12 gauge. All right, we did it. All right. And if your wires fit, just go ahead and connect them in. I'm going to pretend like these end over here, and my wires just don't fit all the way over to where the connector is. So what do we do in that situation? In your red bag, I believe, there is a spool of what should be 12 gauge wire. So if you look on the wire, there will be some writing along it in various places. Probably can't read that too well on the camera, but look for, it should say 12 AWG. So AWG, I think, is American wire gauge. Just looking for the number 12. That's the most important part. Because 12 gauge is, again, based on the rules, there are legal wire sizes based on the breaker size that we used. And we used a 40 amp breaker. 40 amp breaker means you have to have at least 12 gauge wire. You could go bigger. You could do 10 gauge if you wanted to, but you cannot go smaller. And we don't have a long distance that we're short, but let's just say, something like we're short a few inches. You can cut wire the length that you think you need. So I'll just snip these. And then all you're going to do is strip one end. Well, strip both ends of these wires, actually. So I'm going to strip both ends of these wires. Okay, and we can use our connectors that we already have coming out of our speed controller. So we'll open those up, match the colors, put it in, match the colors, put it in. All right, and now we have two bare wire ends that, whatever, we're saying it has to be over here in this example. So we just get two more of those Wago lever nuts. And attach the wires again. So we do red to red. And black to black. So this will work in any of the situations, however you wired your electrical panel. If you're ever short a little bit on your wires, then yeah, it's just one more set of Wago lever nuts, attach it, and now, if we needed our wire path to be like this, we would be long enough. But since my wires reach, they're actually too long, I'm going to go ahead and take these extensions off. I just wanted to make sure that you are comfortable doing that if you need to based on how you laid out your board. But since mine fit, I'm going to go directly into the speed controller connector with the tuck test. Make sure you're pulling on it. OK. And once again, like if I went directly there, we'd have this whole extra loop, which I do not want sticking out in the air, right? I don't want to just put a zip tie sticky here and have this big loop that things can get caught on. Also, this loop, if it's down here where our power switch is, that's going to be annoying. Maybe an inspector would have a problem with that and say the wires are in the way of being able to turn the robot off in an emergency. So we're going to add a few extra zip ties, and we'll just use up the extra space. Now, if you were min-maxing your robot, you're trying to do the absolute best possible job, then we have extra wire length. Extra wire length does a couple of bad things. Number one, it adds weight to the robot. This robot is not close to the weight limit, so you don't have to worry about that. The other thing is the longer your wire run, like wire has resistance. So when we try to send electricity through wire, you're actually losing a bit of your power the farther you go through wire. That's why like power transmission lines have huge, massive cables. So it's slightly better if we clip the wires and we just go directly to it. But I mean, we're talking about, in this case, saving an inch of wire, which is not noticeable in terms of what you're going to be doing with the robot. And in this case, I know we clipped the speed controller ends, the CAN wire ends, but I like to not, especially in a motor like this, I like to not shorten the wire because you can never get it back. I mean, I guess technically you can use these extensions anytime you want to make it longer. So you have that option, but I kind of like leaving it so that it is as functional as possible if I have to reuse that wire in the future. All right, let's go ahead and get this attached now so that we don't have too much loose stuff. I'll take a zip tie anchor, and I'm going to take this first end right back up and in, and that's my first spot that I really care about. So I'm going to get a zip tie right about here. All right, and then find I like the little zip ties for this, but any zip tie that fits will work. And we're going to pass it through, bring our wires up, and we will tighten them down. The other thing that I'm looking to do here is we never really want to pull the wires so they're super tight. You want to have like a little bit of room here. Like if I yank this so it's strained on there, that is a recipe for stuff to break eventually. So give it a little bit. And also we have this white one that we're not using, but we don't want to get tangled in stuff. So I'm going to pass that through at the same time. And then we can go ahead and tighten that zip tie down. Okay, and that white wire is not going anywhere. And now we're going to do another anchor, at least one more anchor somewhere, right? Because we want to take up this slack and have it not sort of running wild on here. So if I sort of like arc it around to where it's going to use up most of the wire, that feels like a good spot for my last anchor. So somewhere right around here. All right, one more little zip tie. Okay, and that seems pretty good. If it starts like bowing out a lot and you feel like it's in danger of being caught on something, go ahead and just add another anchor here, add another anchor here, wherever you feel like you need it. All right, let's snip these. And our big one up here. Okay, next up, this area looks good and complete. That area looks good. Let's flip the robot on its back side. We need to access the bottom of the robot now. So we can neaten up the last few drivetrain wires and make sure they're not getting stuck on anything. So let's pop this up. I think on the back is nice, but all right, I'm going to gently let it rest on the hopper, and we'll try to not move it around to stress it much. I would probably have somebody holding on to it instead of letting it rest on the hopper for too long. Okay, so we have all of these wires here that are actually decently nice that we want to do something with. So like this one, look at all that loop that's here. That could definitely drag on the ground amongst other things. We don't want that. So if I kind of take all of the drivetrain wires, this whole bundle of them here, and I wonder if, can we get up to the churro? Not this one. Everybody else can get up to the churro but that one. Yeah, okay. So what I'm going to do is I'm going to start with the two near wires, or the two near side motors that are right next to it. And those, I'm just going to go up to the churro that's right here. And if yours reach, that's great. If yours don't reach, it is okay to instead just take these wires over to the motor and run a zip tie around the whole motor. But I think mine just reached the churro, so that's a little bit neater, I think, of a place to attach to. So if I get both of these, let's start tightening that down and see how we feel about it. Yeah, that feels pretty good. Okay, and then I'm going to take my other two wires that are pretty tight and don't have much room to go. I'm just going to couple them in to the wires that are now anchored to the churro up there. So we'll take kind of this whole bundle together. And there's no right answer and wrong answer for this. You just want to do your best to make sure these wires are not going to get into trouble. Now the best answer is probably if we had gone and extended wires, we could have taken these wires up to the churro on this side too and run along the churro to go out. So this area in the middle is a place where things could get snagged, but that is under the robot in the middle, and it is a few inches above ground clearance. So I think we don't have to worry about any major problems, but keep an eye on it. You know, if you try going over the bump and it looks like it gets a little too scary, then you might have to reroute or extend your wires. And before we tip it back down, let us trim the zip ties. All right, that is, I think, looking pretty good on the bottom. We do have one more wire, and that was our last white wire that we didn't use. That's sort of like hanging out here, looking like maybe it's going to be a problem. We got several options. We could just go and bundle it to the things that are there. That would work fine. I'm going to throw one more zip tie anchor on for it. And I'll put it like right here. And we'll just tie that one down so it doesn't get into anything. My thought process here is just like, if I have to swap a motor, at least this way I don't have to deal with the white wire again and worry about forgetting it. It's kind of on its own. We know we never have to touch that again. If we have to swap a motor, right, we obviously have to cut these, take the motor out, and then the white wire would go free, and maybe I would forget about it. I don't know. Again, lots of perfectly acceptable solutions. There is no only way to do it. All right, let's get this tipped back. And then we've got 2 more wires to go. OK. Let's do the really easy one next. I think in your red bag, there is an Ethernet cable. So go ahead and tear out that Ethernet cable. And I'm going to undo the little twisty on it. This is going to plug into the radio. So if you look at the bottom, right, there is 2 ports there. One is labeled aux2, one is labeled Rio. We want to plug this wire into the Rio port, which is the one in kind of the middle, in between the 12 volt and the other option. And this is going to come around and plug into, if you remember, we had that PoE injector, that little dongle that we had, and there is that open Ethernet port here. So this is going to plug into that. Okay, I think though, if I keep it flat like this and we can get underneath here, might look to go at least through this part of the power switch. Probably doesn't matter, but let's plug that in. And then I can try to lay that back down flat like that. All right, now we have all of this excess that we have to do something with. And of course, we want to route this in a way that it is not going going to get chewed up in the gear or get stuck in the wheel or any of that kind of thing. Or the belt on the front. So we got a few options. Obviously, in this case, we can't cut the Ethernet cable. We would need the Ethernet crimper and all that to be able to fix it up. So I'm thinking something like this makes sense. So we can route it down around that gear, plenty of clearance around the gear, and then we have lots of room here on the side of the hopper to take up all of our extra slack. So I'm liking that. Let's get to it. It's going to just be the same process as the other wires we routed along the outside of the hopper. So get another zip tie sticky. And this first one, I'm going to go, we don't want to be like 90 degrees on this. Again, gentler curves are better. But I'm going to aim to put this zip tie anchor kind of just by the hole that's here, that big hole on the bottom. And that seems like a good first place. Let's add a zip tie as we go so we keep track of how much extra wire we have to deal with. And again, don't pull it tight, leave it a little loose so there's a little bit extra there. All right, and then we'll do another one. Just trying to stay away from that gear, so somewhere over here seems good. And again, if it starts to misbehave in the middle because you left the gap too big, just add one more. All right, this seems good. Okay, and then looking to have a little service loop, have a little excess loop of material here. So I'm going to want an anchor, probably two anchors here. One maybe here, one maybe down here where it's first going to enter. So somewhere around here seems good. And let's get a zip tie on that one. Tighten that one down. And then maybe one more on the opposite side here. Because I don't really like that's too much for me. So about there. And that seems pretty good. All right, clip the zip tie ends. And the last thing we have to wire on the robot is the Allen Bradley. This is called the robot signal light. I think if you look in the blue Molex box, there is a bunch of different cables and cable housings. We're looking for this one specifically. So it has two wires, red and black. On one end, well, I can open it, and then it will be even easier to see. But on one end, there's just bare wires sticking out. On the other end, there is this 2-pin connector. And this is going to fit. This end is going to plug into the RoboRio, and then this end is going to go into our robot signal light when we're done. So let's go ahead and untwist this. And one of the questions that we have here is this going to reach, or do we have to extend the wires? So let's do a quick test. If we start with the wires up here at the robot signal light, we might need to drill yet another hole in our robot. But all right, so if we run across the top like this to somewhere, I don't know where, and then we go down, and then we get it unstuck from the launcher wheel, and then we go down like this, then we go over to the robot, to the RoboRio, and plug it in, and there is so much extra wire. So yeah, we're cool. We can do whatever we want. So I'm going to get the, let's see, should we route it from the RoboRio, or should we route it from the robot signal light? I think, again, I like this cable. I like the way this cable is. It's got zip ties and ends attached to it. So I'm not really looking to cut this cable and adjust it. So I think I want the extra wire to be maybe here or just laying on top of the RoboRio underneath everything. So I'm going to start by wiring the signal light side, and then we'll route to the other end and deal with any extra cable that we have at that point. So if you remember, on the robot signal light, there is this connector on the back that you just pull out. Just pops out. So go ahead and pop that out. And we need a little flathead screwdriver for this. So let me go ahead and grab a flathead screwdriver. OK. And we take our little wires that we have here. We need to strip those ends. So we're going to, these might be 20, they stripped with 20 gauge. So they might be 24, but worked for me at 20. All right, so we have these ends stripped. And we need one more piece when we wire this. So on the cable here, there are ports labeled LA, N, and LB. So N is our neutral. That's going to be our ground port. That's where the black wire is going to go. But we need the red wire to go into LA, but we also need to connect LA and LB together. So we need a little wire that will jump from LA over to LB. So I think, again, the same wire we used when we did the power for our RoboRio. It's the smallest gauge wire that we have in the bag. We need to just take a little bit of the red. My red is really pink, but I mean, I think it still counts. All right. And we need just, I don't know, let's say a piece that's maybe 2 inches long or less, maybe 1.5 inches. One of the problems is if you try to go too small, you can have a hard time stripping the ends of the wire. So we've got this little piece of wire, and again, on our connector, the goal with this wire is to be a jumper from one to the other outsides. So we just got to strip the middle, or strip the ends, and then we can put them all together. So let's see, this is, let's straighten it out. We're going to be in that 20 gauge, 18 to 20 gauge. This is 18 gauge. 20 is too small. 18 gauge wire. All right, so we'll strip both ends. Okay. And sometimes if you have the ones where you have to like pull off, it's like pulls the insulation too. So if it's too short, sometimes it's hard to get it to work. But we'll fold this in half, a little horseshoe out of it. And I'm going to just stick it into the 2 ports that it's going in, LA and LB, like that. And again, keep an eye on it. If you have any wire sticking out, then you strip too much. Go ahead and trim a little bit off. I'm going to tighten down the LB channel. So on the top here, there are screws, flathead screws. So go ahead and tighten that down to clamp on the LB port. Okay. Then for LA, we're going to take the red wire from our cable and also stick that in. So both of those wires are going to be in there together in LA. And then tighten it down. And then finally, the black wire is going to go in the middle to the port labeled N. So make sure that's in all the way, and then screw it down. Now that everything should be in and tight, go ahead and do a little tug test on all of your wires to make sure they don't come out. And that looks good. All right, so now we're going to go back up. We're going to plug this back into our robot signal light up here. And the very first thing we want to do is find a place to get this out of the way. We don't want this in the middle. So I want to run this immediately over to the inside of our, this is the aluminum piece, that front wall here. So we want to come right against it pretty quickly, and that's where we want to do some support. So let's get more zip tie anchors. And I'm going to do the first one pretty close. I think right about here seems good. And I'll put it just below the top. Yeah, like that. I like that. I'll zip tie that up. And again, I'm going to leave a little bit here so it's loose. Not going to try to pull it tight on that area. And support the anchor as I tighten that down. That looks good. I don't really want to drill a hole in the aluminum for a few reasons. One, it's more effort than drilling a hole in the plastic. Two, if I mess up the aluminum piece, that's harder for me to replace. If I mess up one of the polycarb pieces, well, we made that so we can make another one. But the aluminum piece came this way, so we would have to buy another one or do some kind of harder fix. But also, if we drill into the aluminum, aluminum is electrically conductive, and all of our electrical components are on the robot now. So drilling into the aluminum introduces the possibility that we get shavings in a bad place and short stuff out. So I'm going to route this. I'm going to do another zip tie anchor on the aluminum to get to the plastic section. And then once we get to the plastic section, we can think about potentially drilling that hole and getting out of there. So the only question we really have to ask ourselves is, do we want to stay up high when we run across, or do we want to try to go down low? I think going down low doesn't seem great to me because, we got the bearing, we got this spinning wheel that's going to be right here. So I'm going to go just underneath where that other zip tie is, and that's where I'm going to put an anchor on the aluminum side here. That looks good. And now I think we want to try to get to the outside. Because again, the sooner we get to the outside, the better. The less balls are going to be hitting it, the less it could get in the way of things. So just kind of eyeballing what's here. We going to drill another hole, and I'll stick with 3/8. Why not? So I can see where this is coming through. It's going to come through right around here. So let's get the wire out of the way, and we'll just kind of eyeball like somewhere there seems good. That's far enough away from the other holes that I think I'm not going to create any issues. Far enough away from the edge of the piece that we're not going to create any issues, and that seems like a good spot. Let's drill a hole. And if only I could have foreseen that we were going to drill this hole, I wouldn't have had you spend time cleaning out the gear, because we're going to have to clean out the gear again now that I got more shavings into it. But let's deburr the hole first on both sides here. Try to blow. I think there's one big piece of plastic on here that I'll just kind of scrape off. And you can check again, if your plastic is gone, give this a spin. If it still feels good all the way around, you're fine. All right, mine feels good. Let's pass this cable through. And oh boy, okay, that zip tie just barely clears for me. I had to really kind of do it on an angle to get that zip tie through. So hopefully yours goes. If you have to, you could drill the hole bigger. You could also clip this little zip tie that's on here to get it to go through, and then just put a new zip tie. That's just keeping the end of the insulation in place and keeping the wire protected. All right, so now we're out to the outside. And we can sort of mirror the pattern that's here. I think at this stage, though, I'm going to work back from the other side. So we'll keep all of our excess wire maybe on the side here. So let's go ahead and plug this in where it goes. So on the RoboRio here, in the middle of everything, we are looking for the one port we didn't tape up, which is labeled RSL. And if you look at the side of it, there are some icons. So this icon on the bottom looks like a upside down pyramid, or right side up, depending on which way you're looking at it. That is the symbol for ground, and S stands for signal. So on a robot signal light, the black wire is ground, the red wire is going to be where the power goes to send the signal. So make sure the black wire is towards the bottom of the RoboRio, and the red wire is towards the inside, or lined up with the S. Okay, so this is where it's going to go here. We could bring it up. Now the question is, where do we route this? we could bring it up on the outside here, but I kind of don't like that because that's an area that we're going to smash into a lot. We're going to hit the side of our robot much less than we hit the front and back of the robot. The other thing, too, is let's go ahead and lower this flap down. Now, obviously, we can't attach it to the flap, but we know this flap is going to be here, our movable floor. I think what I'm feeling is if we go across, and maybe we'll do an anchor on the RoboRio in here, then we could go up and get to the outside this way. And then we'll be able to just kind of coil up that excess just like we did before. And something like that feels pretty good. So let's get a zip tie anchor. If you want to put it on your RoboRio, that's an OK place. Like I could put it somewhere around here on there. So sort of middle by the NI logo. If you don't want to put the sticky thing on your RoboRio, you can go down to the wood that's right next to it. And maybe that is going to make the most sense. So let's go down here on the side. And we'll stick that on. And then zip tie that one in place. Okay. Again, I want it, so there's not too much looseness, but I don't want to pull it super tight. All right, so that seems pretty good. Now we have all of this that we've got to get up onto the side here. So first thing is, I know we want an anchor really close to where it's going to first join the plastic. Because if our first anchor is all the way up here, then we have a lot of extra cable that can get loose. So we're going to get one right on the bottom there. It is next. We are getting close to using up all these anchors. You can just buy more of these at the hardware store if you do end up, if you put some in a bad place and you have to change your mind, or you just end up using more than I use. I think we'll have just enough. So I'm going to go right there where this is going to join. Add a zip tie to that one. All right, and then let's just do what we did with the Ethernet cable, which is, let's make a little bundle. I feel like that seems reasonable. All right, so I'll do one more anchor up here, kind of feeding into it. So I have 2 tiny zip ties left. So again, if you need more tiny zip ties, they're not very expensive. But bigger ones will fit through this. So as long as they fit through the anchor, it's fine to use whatever size you have. And then I think I've got 5 anchors left. So we're going to need one more, maybe 2 more for this. Do we want to try to crush it down and just do one? That feels like it's going to fight a lot. It's going to try to spring back a lot. So I'll put one roughly here where they're going to cross over. Zip tie through that. One more anchor for the other side of that loop. And this is my last tiny zip tie. We just barely made it. It's not actually, though. I think I have a bag of a bunch more of these, but the last one that came in the kit. All right. That looks good, right? This wire is starting to feel like maybe you want to add another anchor there. I think I'm just going to let it go for now. But keep an eye on it. Like I said, any wires that look like they're loose or look like they're going to get into trouble, add more zip ties, add more anchors, keep it out of the way. We'll go through, we'll snip all of these ends off, trying to get them nice and flush. And I think we got one more hanging out down here. All right, so that is, I think, everything on the robot wired. Let's just double check. Yeah, we are good. We might still need to do something with our battery wire. We might try to get maybe we want it running a little more this way. We probably will want to anchor this somewhere if we get the chance. And it might be okay if not. We'll see when we get the battery wired and brought in. And so that is the last thing we have to do. Our robot, all wired, but we do have to wire our batteries. So I'm going to clean all this up. We'll bring a battery in. We'll show you how to attach the ends to that. And then we'll put that in the robot and make sure the plug works. All right, we've got our battery and additional supplies that we're going to need. This battery, I think I got from the rookie kit of parts, or the black tote, so the Kitbot kit of parts. So you should have one that looks like this, but there are a few different brands of battery that are legal, so yours may look a little different. That's fine. And then this was just loose in the bottom of that crate, but there is this little baggie of hardware that we're going to need to use. And this has the bolts and some washers and some lock washers in it. So you have to dig through the bottom of the crate to find that. If you buy a different battery, your fasteners might be a little bit different if it's a different brand, but it's going to work roughly the same. And then we have another one of these Anderson connectors. So this is the big connector that we attach to the robot side for our main power. Two of the same connectors will plug in together. You can buy these connectors separately and try to make your own cable. I would strongly suggest that if you don't have any more of these in either your rookie kit of parts or the kit of parts that you got, to buy more. So it's a little hard to make this end of the cable. It's going to save you a lot of time, especially if you don't have the right tools or the right equipment to be able to do the crimps and put it together. It's going to save you a lot of time to just buy it built. And in fact, if you buy ones that also have ring terminals on the end, that's even better. Going to save you even more time. All right, but I've got the ring terminals that we used before, and we'll use the same crimper that you used. However you were able to crimp them on the robot side, we're going to do the same thing here. Okay. Our first question, though, is when we put this in the robot, what orientation do we want these battery leads coming off of it to be facing? And so we can kind of test it in the robot. I will say, safety-wise, one thing before we start, these leads right now, mine came uncovered. Totally fine if I touch them, not going to hurt me. Actually, I can touch both of them, not going to do anything. So the 12 volts is just not enough voltage to pass current through your body. Your resistance is high enough that it's not going to hurt you. That said, something like a wrench going across or a screwdriver going across and touching both of those leads at the same time would, in fact, be a bad thing. So that will spark. Sometimes it arc welds the wrench in place. So then, it just keeps dumping more and more energy into it. So if you want to be extra safe, first of all, just be careful. But if you want to be extra safe, you could take a bit of electrical tape. And you could cover both sides. But really, if you cover one side, that's going to do most of the work for you. So I'll just cover up one of the leads here. And now I can't really easily bridge them together. So we're in kind of like a good, safe working situation. Now, what we can do with this is we want to put it in the robot and figure out what orientation it's going to sit. So I can put it in the robot facing this way or facing this way. That's the first question. And then when we put our connectors on, I think we can have them sitting up or sitting flat. And we have to decide kind of which of those two orientations we want to do. So let's, drop the battery in one of the two directions and start thinking about it. So if it's this way, remember this floor is going to come down, and that's going to be right above it. So I think in this situation, I'm not sure if we have enough room for this cable to go upright and still work. So now, if we're thinking we have to have it tipped out, if it's tipped out like this and I try to bend it around back, that's always going to be sticking out of the back of the robot. So I'm not loving that. So I think the way that I want to put the battery in is with the leads facing towards the middle. And then, do we have room? I guess we have to have room, right? So if we come out flat like this, then do we have room for this to bend around, right, and make it to where we want to plug everything else in? And I think, so our connector would be like this, and that looks just about perfect, like we make it all the way over there. So I think that's our goal. We're going to aim for it to be mounted in this direction with the leads in the back, and we're going to have our ring terminals coming off like this, and then we're even going to do our best to sort of train this battery cable to be moving over in the direction we want it to go. Okay, so first step, let's get the ring terminals crimped on. So we know it's going to be, and we can sort of twist this over if we have to, so if it's facing the wrong way, it's not a big deal. So we'll pull these insulation ends off, get a couple more of our ring terminals out here. And one of the things with these ring terminals is, one of the reasons I was talking about, like, we're kind of either going to be flat or upright, is they're a little bit too tall to be in on an angle. That corner of it kind of hits. You could go ahead and file that corner down a little bit in order to make it fit. But this is the main battery connection, so I feel like I kind of want to mess with it as little as possible. All right, so we said we're going to go like this, and we're going to be bent off to the side. So I want, when the cable's flat, I want to try to crimp this connector on perpendicular. So if the housing is sitting flat, I want my connector to be up and down. Now the wires will twist, so if you don't do it, that's not a huge deal. All right, and then let's go ahead and get our crimpers on there. And remember with this, you just squeeze as much as you just crush the heck out of it. And then I'm going to do a second crimp in the spot next to that one. Again, giving it as much as I can. All right, and we'll pull on it. It's not coming apart. That looks good. And then the red one should be facing the same way. So I'm going to get the red connector on here. Make sure you get every strand inside. And I'm going to have this one facing the same way. Maybe I'll rotate it. But still, you want it vertical. So as long as it's vertical, you're going to be OK. And then let's crimp this one down. And move over, and I'll do it a second time. All right, that seems good. Now we'll bring our battery back over. And so the red side's covered. I'll do the black side first. I can attach this on this side or on this side. It doesn't really matter. I think I like putting the tab on the side that the wire is a little bit better, just because it kind of like, I don't know, it kind of like feels more compact. But it doesn't really matter. All right, and let's go ahead and open up our baggie of hardware. And we'll dump that out and take a look at it. So we have 2 bolts in here. And in addition to the 2 bolts, we've got 2 nuts. And then we've got regular washers, and we've got these split washers. So we're going to use one set of everything on each side. OK, so let's go ahead and start with, we'll start with the bolt going through the tab on the battery. And then I'm going to put the connector in, my ring terminal. Then we're going to do the regular washer next, and then the split washer, and then the nut. And this nut is a little sticky, so when you try to get it started by hand, it might not spin very far very easily. So just keep that in mind. And it's also pretty full with the terminal on there. There's not a lot of extra wire. So our goal is sometimes if you hold the connector, you can get a little bit more space on that bolt. Let me try flipping it around and see if the other side will go. All right, I think I got it started now. And you definitely want to feel it going by hand first before you start tightening it, because we don't want to, we don't want to have these ones cross-threaded. And now we'll switch to the tools to tighten it. So you're going to need 2 5/16 wrenches. So I have one 5/16 wrench and one 5/16 socket, which is going to work for me. There is a Phillips head spot here. which can work, but it's hard with the Phillips head to really make it as tight as we want to make it. So I'm going to go ahead and get this so it is starting to get tight, and then I'm going to adjust the wire. I'm going to try to be sticking more or less straight flat. I definitely don't want it sticking up because it's going to hit the floor. But I don't know if it needs to stick down. If it sticks down too much, it's going to be harder for us to insulate it afterwards. So get that on, and you need to make this pretty tight. Okay, so after you're done tightening it, go ahead and see if you can get this to rotate. If you can get this to rotate at all, it's not tight enough. So that one is actually just barely, when I push down there, it just rotated a little bit. So I'm going to try to get a little bit more of a turn. It seems like my socket on the bolt head is slipping easier, so I'll try to tighten on the nut side this time and just hold the socket in place. And that was a little bit more, and that still moves a little bit, so I'm going to give it one more tug here. All right, that is about as tight as I can make it, and that is not moving anymore. All right, perfect. That's one side done. Now, well, almost done. We're going to go ahead and insulate it. Now, if you have heat shrink, it's weird because we're doing this one at an angle, but you might be able to get some heat shrink that goes over that, and you can heat it up with a heat gun or a lighter or whatever you have. That would work, but we did get the black electrical tape in the kit of parts. So this is the black wire, our negative wire, ground wire. We're going to go ahead and use the black tape to match. And it's going to be a little tricky going around the corner. So if you have to do multiple pieces of tape or you have to keep trying, the goal is just make sure everything is covered. And what I like to do is I like to start with a strip and bring it down on the inside here where it's the hardest to kind of get. And then I'll wrap one end around, trying to bring that in as tight as I can, and then I'll bring the other end back around. And then we'll work our way around the corner. And it's okay if we wrap the same place twice. We're just trying to get everything really nicely covered. And if it ends up being 2 layers, that's probably even better for us. So when I'm spiraling up here, I'm spiraling up slowly so we get plenty of coverage. And then at the end, we'll give it a snip and finish it off. Now, if you did that and you're looking down around the bottom here and you're like, oh, I still see some metal showing, or if the corner is starting to poke through, you can wrap the whole thing exactly the same again, but sometimes I'll just take like a little section of it, a little section of tape, and just try to get that bottom, right, that down on the bottom section here covered again, and sort of like wrapping that one through. And that seems to work pretty well to get everything covered. All right, so that side looks good. Let's now move over to the red side. We'll pull our safety tape off and line that up. So same pattern. We're going to do the bolt through the middle. Okay, and then we will do the flat washer. So we'll do the ring terminal, bolt, ring terminal, flat washer, split washer, and then we try to get that nut started on there. Okay, that one wasn't as hard as the first one. So that's good news. And now we start tightening. Okay, when it starts first getting tight and we can still kind of move it, I'll sort of flatten that out just a little bit so we have room underneath for our electrical tape. And then let's go ahead and keep tightening down. Oh, it will rotate sometimes when you tighten, so just be aware. The angle, again, if it's off a little bit, no big deal. Oh, this one really just wants to move. All right, that's fine. But let's try to get it nice and tight. Okay. And I can still just barely rotate that. So we're going to give it another bit of tightening. And that's got to be close. All right, I cannot move that. That's good. So this time, we're going to switch to the red electrical tape. So there are some rules when you have constant power side or supply side wires. You need to have the colors matching. So red always needs to be the positive wire. Black always needs to be the negative wire. So even the electrical tape here should match. You should do red and black electrical tape. You could probably get by with black on both sides, but definitely don't do red on both sides. So that's something that an inspector at the event might have you change if they don't like the color that you used. All right, so let's do the same thing. Let's get down to the bottom, and we'll bring the one tab over first. And then we'll go back around. And my tape is sticking to itself. Okay, I would definitely want to get around that corner again, right? Because that sharp corner is a place where it could definitely start to break. And then loop it back under. And then we just keep spiraling. Okay, that one, the end of my tape twisted, so I'll just go back around again. Cover it up. And work our way up towards the insulation that's already there. And cover it up. That looks good. Okay, and then we said it's going to go in the robot like this, but we need the wires to be facing, it's going to go in the robot like this, and we need the wires to be facing this way. So one of the things we can do is just kind of try to bundle them, up in kind of a good little flat package here. And I actually think, if we put a zip tie here to kind of hold it that way, that might help make it easier for us to put the battery in and out throughout the season. So let's see. Maybe I'll just do one on this. I think we probably need to go around both. Let's try it. See how it works. Okay, that's pretty good. I don't think I want to make this like insanely tight, but I don't know. Let's snip these and see if they're helping at all when we go to put it in the robot. If not, you can feel free to snip them off and no harm done. All right, so in the robot, to swap the battery in the robot, the first thing is the flap. We need to move the flap out of the way. So push that up and in. And then we can take the battery, and you can't really do it from this direction. Maybe if you force and bend stuff, but nah, you got to reach up and drop this down in from the top. And then if you remember, we're going to take that Velcro strap, and the Velcro strap goes over the battery under the little flap spot here, which this is not the easiest part to grab. Pull it tight, pull the Velcro back up over, Velcro that in. And then if we look at our connectors over here, they are pretty much in alignment to plug in. So I will go ahead and plug those in. And that sits in a really nice spot for me, I think. So now if I lower my floor down and re-Velcro that in, okay, that is sitting nicely. It's not really hitting anything. Yeah, that's in a great spot. Our wires are not pushing up on the floor. They're sitting perfectly underneath it here. So that's looking great. Let's do one more test now before we call it good for this video. And that is, we're going to try to power it on and see how things go. So when we do this, we're going to look for a couple things. And it's good to prime yourself and be ready to know what you're going to do if something goes wrong here. So the first thing is we have the power switch on this side. And if you remember, there's the lever. The lever, when we push the lever in, that is going to, we might want to do, we'll see. If your wire like this is too close to the button and you're worried about it, you might want to add just an extra zip tie, but I think I'll just kind of push on mine and see if that keeps it out of the way. Seems okay for now. So this lever, pushing that in is going to turn it on. Pushing the button down from the top is how you turn it off. So there is a different on and off button. Now, we're going to turn it on, and you're going to be immediately ready to turn it back off. So you're going to look to see if there's anything that is smoking, or if you feel anything heating up or weird buzzing sounds. Just go ahead and turn it off. Double check your wiring, and then go ahead and turn it back on again and see what's going on. The next thing we're going to look is after we turn it on, we're going to start scanning all of the inside stuff for lights. So there'll be lights on the RoboRio. There should be lights on the power distribution hub, and there should be lights on all of our SparkMaxes. So we're going to just kind of see that. And if anything feels off, feels weird, you can turn it off, check some stuff, think about it, and then you can go ahead and turn it back on and try. So let's do that. We're going to turn it on, and I'm going to keep my finger ready to turn it off afterwards. All right, so on, and I'm just looking at everything. I don't see anything bad, no smoke. And now looking on the inside, right, I've got all of my speed controllers, all of my SparkMaxes here. I've got lights on all of them. Looks good. This one was kind of flashing differently. If that's the case, don't worry too much about it. On the RoboRio over here, I have light for power, and looks like light for RSL. That's cool. We have a voltage on our Rev Robotics PDH here, saying 12.2. We got lights on there. It's actually interesting. So the lights that are lit up are no fuse present or no circuit breaker present. The ones that have a circuit breaker are going to flash. So that'll let you know. If one of your SparkMaxes didn't light up, this is one place to check. Make sure that your fuse is in this location. Make sure that red and black are always matched up. That's the two main reasons why a SparkMax might not turn on. And then my last fifth SparkMax on the side here, also you can just kind of barely see that that is in fact lighting up. Then if we look higher up on the robot, up here, our robot signal light is lit up. That's good. And our radio has lights. So that's it. That's all the components. They are all lit up and powered. I'm going to go ahead and turn this off. You might want to, at this point, also charge up your battery because, when you come back and you start programming it, you're going to want that battery fully charged. But this robot is completely wired. You can jump to the programming video if you're ready for that and get started there. But you should be a little bit careful. The robot without anything on the sides, on the bottom, which are going to be bumpers that we're going to put on that help protect the robot and also help protect the room you're in or the field you're on. So if you start programming without that, just be extra careful when you're driving it around. You don't want to be smashing the metal frame of your robot into walls, tables, people, and you don't want to damage the robot. So that's why our next video is going to be building and attaching the bumpers on the robot, which are going to help keep it safe. But whether you get the bumpers on or not, you can get started with programming, especially if you have a different programming team and team that's going to be building your bumpers. All right, that is it for this video. We'll see you in the next one. But before we go, let's give a special thanks to Argosy, first, Aramco, and Team 302, Lake Orion High School, for hosting our studio.